All right, so let's get started. I want to say a big thanks to the MSP community, specifically the Cyber Call. I was just at the Cyber Bay conference down in Tampa with Arnie and Andrew. How many of you guys are all with MSPs? If you want to type in and let us know how many of you are with MSPs or MSSPs, that would be awesome. All right, we got some MSP representation. Thank you all. We really appreciate you all for coming here. And we know it takes a lot of time and effort to show up and do these things because you'll have jobs to do. And we'll talk more about, people showing up and helping us and really making this community what it is. And by the way, you are definitely part of a community now. You may have been on the internet and thought to yourself, wow, Twitter is a cesspool. That place is as bad as Zach's basement or John's office where his cat peed all over the walls. I don't want to hang out in X. I don't want to hang out in those particular places. Well, congratulations. We've got a poop-free environment. Poop-free environment for you all to help out. A managed service provider, Mike 99, or a managed security service provider. A managed service security provider is what an MSP is. So, like I said, you've got a community and we try to take care of our community and we try to help out as many people as we can. And yes, we do actually try to keep things clean. And there's now Jelly Beanster, Brian, time traveling nerd herder, just shared a link to the Black Hills Infosec community. We're now up to 54,000 members. As my son likes to point out, because he plays a lot of Minecraft, that's cute. But we have 54,000 computer security professionals, about 7,000 are on right now. And it's a moderated environment. We aren't being like free speech purists. It's like, no. You come in and you start ruckus and you start shit. We're going to kick you out. Probably get a warning first, right? You're going to come in, you're going to talk politics or religion, any of that stuff. Like, no, we're not going to have that here. This is for security and helping build each other up. And we're trying to keep the bots and the disinformation and all that garbage out of our waters. And this is our waters, and we want to keep it that way. So what are we covering in this section? Just for the record, we are doing intro to SOC core skills, right? People, like you're all here for that class, right? SOC core skills. Just want to make sure I'm in the right class. All right. Because I've been teaching a lot. I've been presenting a lot. Like even before a couple of weeks ago at Wild West Hack and Fest, I taught the week before that. And then I taught I taught DoD classes for network threat hunting. And then I had a at night thing for some people in Europe. It's been like nonstop. So sometimes I don't even know where I am. I tell this joke a lot, but this happens a lot of time. Whenever I'm traveling, I don't know where I am. I wake up in the middle of the night and I don't know which direction the bathroom is. And I have a tendency of walking into the walls. Or I'll wake up in the middle of the night and think I'm someplace other than home. And I get really uncomfortable because someone clearly crawled into bed with me. And I'm trying to figure out how the hell that happened. And then you realize that's your wife and you're at home and that's perfectly normal. So yeah, it's a bit strange. So whatever. So we're going to be covering some core concepts in this class. And it's core concepts that a number of other classes kind of gloss over. Talking about intro to Windows, we're talking about intro to Linux, talking about intro to TCP/IP, which is where we're going to be starting today. We're going to be opening with that particular section. We're going to be covering the basics and core fundamentals that are required for a SOC analyst. And this is a new version of this class, actually. We have a couple of new labs. We'll be playing with Scapy, maybe today, maybe tomorrow. Maybe on Thursday, but we're also going to be playing with tools like Hayabusa. We're going to be playing with tools like those are the two big ones that I can remember, right? Scapy, Hayabusa. We'll be doing email analysis using Sublime. Big shout out to the fine folks at Sublime as well. So we do have new labs. But that also means that we kind of removed some labs. We'll be talking about overlap here in just a little bit, but we're going to be moving a lot of the stuff dealing with vulnerability analysis and a lot of the stuff dealing with web app analysis because the SOC core skills section got so voluminous and what we needed to cover in this core thing. That doesn't mean they're gone. They're just getting pushed into the intro to security class that we have as well. So we'll be hitting these basic cores and fundamentals, and these are the things that everyone needs to learn in order to work at BHIS, to work in our SOC. And this is meant to feed into the intro to security class and then also the cyber deception class. So there is some overlap. Each of the classes that I teach are designed to be able to stand on their own 2 feet, right? So the SOC core skill class can stand by itself. The intro to security class can stand by itself, and deception can stand by itself as well. Now, that overlap is becoming less and less and less as time goes on because we're getting more and more and more that's required in order to be effective in these different job roles, whether it's security, whether it's doing a SOC analyst or general security rather, a SOC analyst or doing deception in your organization. So we are going to have some overlap associated with it, and we're going to have some overlap in the various topics as well. So in the future, this class will feed into the intro to security class. Intro to security will feed into deception as well. Now, all of these classes are pay what you can. And I've got a lie on this slide, a small lie. It says, in the near future, any class taught by me will be pay what you can, and that is not true. The one class that I have that is not pay what you can is Intro to Penetration Testing. That is not an pay what you can class. That is a full commercial class because I literally give away all the secrets on how I run BHIS. And I figure if I'm giving away all the secrets on how I run my company and how I stood up Black Hills Information Security, I should at least charge for that. But it's a good primer for organizations that want to do pen testing or people that want to get into pen testing to have better understanding of what penetration testing actually is. And as part of this, also, we have a webcast that you all can check out called The 5-Year Plan. It's my 5-year plan to get into InfoSec, specifically into penetration testing and getting started with that. And you should all check that out. I think we have Ethical Hacker. Nope, that's my Intro Active Defense Cyber Deception class from Ethical Hacker. But if somebody could post a link to the 5-year plan, I did two separate versions of it. Second one, I was really sick. Had a really bad cold. I apologize for that. Probably need to redo that one. But it goes through the core skills that someone needs to have to become a penetration tester. How do you get started in computer security? And it's designed around somebody that's going to college, right? Or possibly high school. You're going to take 5 years, and what are you going to do in each year? Now, I've seen people take that 5-year plan and really, really knock it down to like months, like knock it out in just 5 months. I had some people they were actually, oddly enough, they were in the trucking industry. They could listen to our podcasts and take our class, and they would drive across country, long haul trucks, and they would listen to this stuff. And they really narrowed that down in their time off. They would sit and they would like do the labs and do the stuff. So you can actually do it very quickly. And the other group that I saw do it was very strange. It was Cluj-Napoca, which is in Romania. It's right in the center in Transylvania. Transylvania 6, 5,000. But it's right in the middle of Transylvania. Really, really super cool town. And I had a bunch of university students there. It's like the university hub that they had gone through and kind of developed a lot of their curriculum around it, which is really cool. Now, how does this relate to you and what we are doing in this class today? Well, this relates to all of you from the point that it kind of short circuits a lot of that. So if we're talking about operating systems, we're talking about networking, we're talking about all of these different things, that's going to be covered in this course, right? We're going to be doing those topics. So this like knocks a couple of years off this plan for somebody that's at university. And it really helps someone that's trying to get started with their job in computer security to be better at what they are actually doing. So before we get into kind of the mindset and the overall narrative of what we're going to be working with, I want to spend a couple of minutes and I want to talk about AI, right? When we are looking at artificial intelligence, I've been dealing with this question for a while with a number of students, and I think it's very important that we discuss it in terms of how it relates to this class, because there's a number of people that are looking at AI and they're basically like, well, if AI is taking over everything, do I need to actually understand anything as it relates to computer security, especially core fundamentals? And I want to address that briefly. Let me pull this over, this down, move this over here, and then we'll start up a new ChatGPT session, new project. There we go. Right. So let me share my screen back out real quick. All right. So if you are looking at like ChatGPT and you're working with ChatGPT, you can kind of be under the delusion that ChatGPT can answer just about anything. And ChatGPT does a really good job of doing some really basic things, right? So if you could say like, what is TCP IP, right? And it's going to break down and it's going to give you a little bit of, TCP/IP stands for Transmission Control Internet Protocol. It's a fundamental. Here's the definition. And by the way, all this shit is stolen, right? Like it's stealing this from tons and tons and tons of places online. And this class isn't really designed to crap on ChatGPT because a number of you, well, let me see. I should be screen sharing. It looks like my screen is sharing in Zoom. I don't know if I can get a confirmation as to whether or not screen share is working. It'd be a shame if that goes down as well.
It's working on my end. Looks good.
All right. Sounds good. If we can kind of help them out, probably be a refresh, I guess. So we just got that, which is a good breakdown of it. And I do really love how it broke down. I'm just telling you this right now. Did you notice how in TCP/IP it said like the 4 layers of the TCP/IP model? We call that foreshadowing for a rant that I'm going to have later. And it gives us a pretty good definition, I suppose, of it. But let's say I don't know anything, right? How do I find a hacker on my computer? Right? I'll just put that in, right? Because now ChatGPT thinks I'm an idiot. So it's thinking longer for a better answer, and it's going to give us an answer on this as well. Hey, Nicola, can somebody tell CTF support? Let's just not redo the entire architecture of MetaCTF. Let's try to wait for Amazon to do that. There you go. There we go. All righty. So if we did this, this is an answer that is okay-ish, right? The problem I have with this answer that it's giving you is even if we use ChatGPT, right? Like if we go right here, immediate priorities contain, don't reboot, power off, preserve the evidence, clean device, change important passwords and all that stuff. This is good high level stuff. But when you get here, it says, let's look at the running processes, task list space /v, which by the way, just want you all to know that our class is better than ChatGPT because we're going to be doing all kinds of cool stuff with task list. And that's going to be the bar. Can John Strand beat ChatGPT as it relates to training people how to find bad things on computer systems? I'm feeling pretty damn good about this right now. But it's saying task list where PowerShell get process, sort object, CPU descending, select object first 30. Alrighty, I have very big problems with both of those things. And you're going to see that whenever we get to the Windows section. Netstat NAO, probably should do netstat NAOB, so we can get the process ID and the corresponding dynamic link libraries associated with it. Auto runs, trusted. What do we have for auto start entry points? The problem I have with a lot of this is this isn't giving you context, right? It's not giving you a lot of context as far as what you should be looking for and what you shouldn't be looking for on your computer system. And some of these things, I don't want to say they're wrong, but they're not going to hit the mark very well on that at all. So when we're looking at moving forward with ChatGPT, it's very easy for me to say, well, ChatGPT got it wrong, therefore AI sucks. Haha, we win. It's not what I meant. Whenever you're looking at the usage of something like AI, which is absolutely going to be something that you are all going to be doing in your career, the more you understand about the underlying properties of what is happening and what you're asking ChatGPT, the better the results are for ChatGPT and what it actually gives you. So if you're just trying to do computer security and you're trying to use ChatGPT, you're probably going to get very kind of shoddy answers, like these kind of big motherhood and apple pie type answers with very little context, very little explanation. And it's not going to be of very much value for you. However, if you can actually hone your request and what you're doing, and you're asking very specific things, and you can provide ChatGPT with more data about what is going on, then you actually are able to ask more intelligent questions, right? So I could say something like when using netstat NAOB, why do some processes have cannot obtain ownership information? All right. Now let's get it, giving it a very, very, very specific question, right? Not obtain ownership information. So now we're giving ChatGPT a very specific pointed question. Let's see how it comes up with this. Yep. And now we're starting to get a very good answer out of ChatGPT. So with this particular point, when we have like a broad question, how do I find a hacker? ChatGPT is giving you garbage answers, right? It's very, very milk toast. It's not even accurate in some situations. But if I can ask it a highly targeted question, then I'm getting a really good answer. It's saying, here's what you got going on under the hood. Process ID is almost always corresponds to the system process. It owns things like TCP IP stack, SMB, OS networking services. These don't map into user node processes. And it's great, right? This is a good answer. But I had to feed it more context around a question in order to get the quality of answer that I need to be able to do my job. So when we're talking about what it is that we're doing, right? What we're doing in this class and how we're doing in this class, you shouldn't look at this as an either or situation. Like, oh, if I just use AI, it's going to be able to answer all of my questions. But rather, you should be looking at it. What are the core fundamental components that you need to understand in order to ask and provide context to AI and be able to understand the results with more clarity? All right. So that's how this kind of interleaves with artificial intelligence as well. Nicola just said, do destroy them if you can, since it's burn credits to start them up. If you lose credits because of it, just let them know, and they'll give you some credits to make up for it. Once again, a round of applause for the fine people at MetaCTF for helping out, because I don't know if you know this or not, MetaCTF, I don't think has slept in like 3 weeks. Like they did Wild West Hacking Fest, they did Cyber Bay, which is a huge event, and now they're here. They're helping us out. Amazon just went down. They're doing an amazing job, and they absolutely deserve any round of applause that we can have to help us with this and get it up and running. All right, so when we're looking at this course and we're setting it up, we're really going to be looking at all of these different components from the perspective of you've been compromised. So now what? What do you do to actually detect that you've been compromised in your organization? And this is a lot more fun and more applicable than simply looking at a system and like going through the man pages, right? Because God forbid any training organization would just give you man pages for tools in PowerPoint format and charge you thousands of dollars for that. That would be awful if anybody were to do that. So instead of kind of doing that man page read to you type thing, we really want to make sure that we're going to be looking at what the commands are, how those commands work with each other, how they tie together, and then getting you hands-on with those various commands as well. So everything's going to be looking at this from the perspective of, are you in fact compromised? If so, now what? Because first steps are incredibly difficult in computer security. You get into a lot of issues where people are afraid of mistakes, and that leads to paralysis, right? One of the things that ChatGPT said, if we go over here, it just saw it quickly. It mentioned, it mentioned you don't want to damage the evidence, right? Well, I think it was up here, but there was one of these things that it said where it was like, you don't want to reboot or power off. You need to preserve the evidence if it's damaged. Preserve the evidence. Take photos of the screen, note times, open files. This is enterprise, involves sensitive data. Call your incident response team, which I think is good. But when we're kind of talking about that preserving the evidence, you get into this paralysis that occurs in computer security where people are afraid to take any action simply because they're afraid that taking any action will contaminate the evidence and it's not going to be admissible in court. You're going to get in trouble and all these different things. So a couple of notes about that before we get too crazy on this for anyone. The first thing that I want to kind of hit is You can absolutely take action on a computer system. There's nothing wrong with doing that as long as it's documented action and you've talked about it within your own internal organization before you take that action as well. You're inevitably going to have to interact with a computer system that is compromised. And a lot of the commands that we're dealing with in this course are very much motherhood and apple pie type commands and things that we would do. So keep that in mind. We want to keep moving. We want to create our incident response procedures, but it's really predicated on having a really good understanding of what is happening and what these commands actually do. We need to keep moving. We need to have a plan. So we got to cover a lot of these basics and fundamentals because when you're looking at incident response plans, a lot of organizations have incident response plans that look like this, right? It's just this flow chart of just pure hell where you end up in a scenario where it's like, you got to do this, then this, and this, and this, and this, and this, and this. And really, there's only one flow chart that I think matters in IT. And it's not something that I necessarily agree with per se, but it is an absolutely valuable one when you're looking at it is all right. There's this flow chart that I think is fantastic. See if I can find it. Problem solving flow chart. Does it work? Yes, no. Let's go ahead and go to this one. Does the damn thing work? Yes. Don't touch it. Not a problem. Does it work? No. Did you touch it? Yes. You idiot. Does anyone else know? No. Hide it. Does anyone else know? Yes. You poor fool. Can you blame someone else? Yell. Yes. No problem. Can you blame someone else? No, you poor fool. Did you touch it? No. Will you catch hell? Yes, you poor fool. Just, ignore it as a problem. This is ultimately, like, if we're kind of watching what's going on with Amazon, I'd have to say it's a little bit of this, right? Does it work? I think in Amazon, we can say, no, it doesn't work. The Virginia data center is still down, right? Did you mess with it? Well, we don't know. If anybody gets a good article about Amazon messing with DNS or any DNS changes, I wouldn't be at all surprised if they end up blaming an intern. Like, well, those interns, they made DNS entry changes and everything changed. And interns, what are you going to do? So then they can blame an intern for it, right? Can you blame someone else for it? Is another good one. Well, it's not our fault at Amazon. It's your fault for not setting up appropriate redundancy so that you could fail over to additional like locations, right? This is literally the only flow chart that I see consistently work in IT. This is just the one we see people use. And I'm not saying I agree with it. I think it's horrible that we blame people for things like that. And of course, we just got the wonderful little teddy bear, angry that it's Monday. Yeah, it seems like the entire internet has a case of the Mondays, right? I mean, hell, if you weren't here, my daughter literally blamed me for her website for her classes being down by asking me, Dad, is BHIS pen testing this? Which really bothers me because it's like, I don't think of any situation where we've actually crashed entire networks enough that my kids would be like, that's the default answer is dad's company crashed the internet. Like it hasn't happened before, sweetie. Why do you think it happened now? Right. So at any rate, so that's the flow chart that makes sense. But we see people constantly trying to develop flow charts, right? If this particular attack happens, then we're going to do this, and then we're going to do that, and then we're going to do that. And there's a great quote by Dwight Eisenhower. Plans are useless, but planning is indispensable. Whenever you come up with detailed plans on how you're going to deal with an attack or deal with a hacker, the attacker, unfortunately, isn't going to follow your plans. You just aren't. Another way to say it is plans rarely survive contact with the enemy. Or my favorite way of dealing with it, Mike Tyson's quote, everyone has a plan until they get punched in the face, right? And then that plan goes out. But I also said planning is indispensable, right? I think that that's a huge part of what we're dealing with computer security is to have that planning is indispensable part of it. So how do we do planning without developing these highly detailed plans on how we're going to handle an incident, how we're going to handle attacks against our organization? Well, it turns out Legos will show us the way. And this truly was the nexus for us creating backdoors and breaches, right? And I'm going to talk about that more on the next slide. I like to look at when we're dealing with an incident, I like to have organizations that have discrete areas of training where the organization has gone through and they have policies, processes, and procedures. And then they have people trained to do very specific things, right? So let's kind of look at this like, let's talk about plans, process, and procedures. So policies, processes, and procedures. So an example of those three things would be a policy is we make pies. Okay, high level policy. A process would be the directions for making pies, right? It would be like you're going to roll out the dough, you're going to mix eggs and flour, you're going to do all of this, you're going to turn on the oven, you're going to use the mixer, you're going to do these things. And the individual procedures are the step by step instructions for how to use an oven, for how to use a mixer. And that's the difference between policy, process, and procedure. You should have very good detailed procedures on how to handle all of the different components that exist within your incident response infrastructure. What are the various technologies that you have in dealing with an attack, and what is the training that you have? Then things like checklists in order to handle these incidents. And what this allows you to do is it allows you to assemble your overall approach for responding for an attack, and it allows you to customize that approach on the fly. And that's one of the things I love about the Lego movie, right? You know, I think his name was it Elliot? Was that the name of the lead character? I can't remember. I think it was, or Emmett. It was Emmett. Yeah, there we go. It was Emmett. Emmett. And one of the things I thought was so cool is if you had Batman or you had Emmett, if they encountered a problem, they could take the Lego bricks from around them and create an ad hoc solution for that problem on the fly. And if you do planning correctly and you set up your own personal training and your own growth correctly, then you're going to be able to deal with almost any cyber problem that hits your organization because you haven't gone through and created highly detailed flowcharts on how you're going to deal with everything. You have a lot of discrete knowledge in different things and how you can respond and how you can stack them. And that's ultimately the genesis for backdoors and breaches. So Backdoors and Breaches has these blue cards. We have endpoint protection analysis, we have crisis management, we have endpoint protection analysis, which is different than endpoint analysis. NetFlow, user entity behavioral analytics, we got isolation, internal segmentation, and server analysis. And all of this is free. Like you can buy the cards, absolutely. But you can also go to play.backdoorsandbreaches.com. Let me throw this in to Discord. There we go. Oops. That is not the key that I was looking for. I'm going to put it in resources as well. If you're curious, the slides are in resources. So all the slides I'm doing are there. And this entire game can be played with anybody online. You can even do it here, right? So we can go to Core Deck V3, which, yay, it works. That's awesome. And Backdoors and Breaches automatically creates an incident for you. Like as soon as you come here, like if you're working your own internal team, you have to work through that incident. Yes, Brian's giving us a link for the Shopify store for Backdoors and Breaches. And yes, we do actually have the ability to sell Backdoors and Breaches in Europe now. We have a distributor. Actually, it's in Poland, it's in Krakow, and our office is there, and we have it there in the office. But this automatically creates an incident for you. So if I flip these cards over, it automatically created an incident of an insider threat that used broadcast, multicast protocol poisoning, HTTPS as exfil, and then they're using accessibility features. Each of these cards represents a different phase in the attack. So red is initial attack and compromise, yellow is lateral movement and escalation of privileges, brown is C2 and exfil, and purple is persistence, right? Now, you can take this and you can refresh this, and it's going to create a brand new incident. So now it's bring your own exploited device, credential harvesting, bits as exfil malicious browser plugin. I refresh again. And then it's like, you know, trusted relationship, service modification, background intelligence transfer again. And you can click on any of these and get additional information about what that particular card does. All right, so you have all of that set up and ready to go. Awesome. Now, what do the blue cards have to do with it? The blue cards are what drive the majority of what we're doing in my Pay What You Can classes. Because in this class, we're going to cover memory analysis. right? How do we actually do memory analysis? In this class, we're going to talk about endpoint protection analysis. In this class, we're going to do some network threat hunting. In this class, we're going to talk about logs. So a lot of the stuff that we discuss in this course and in the intro to security class are covered in backdoors and breaches. And you personally and your organization should have documented procedures for every single one of these blue cards. And further, everyone should be trained in how to work these three cards. So, or not three cards, these blue cards, right? So, this is what you should be focusing on. You shouldn't be focusing on this grand scheme of all of these different things and how you hack a network. You shouldn't be focusing on the exploit du jour. You shouldn't be focusing on, using Metasploit. You shouldn't be focusing on writing 0 days. Focus on these core fundamentals. One of the greatest instructors I ever had, Ed Capizzi, who's now working with us, running our GRC, helping us set up our GRC practice. He had this great quote. He said that good security is nothing but an inspired application of the fundamentals. And that hit me right here, right? And that should really be an encouraging thing for everyone that is in this course and everybody that's working, is you should understand that computer security isn't about the 0-day exploits that you're dealing with. Good security should absolutely be about core fundamentals. And if you're starting in those core fundamentals, you're building up a better understanding about your overall IT infrastructures that you're responsible for, but you're also kind of dealing with these core fundamentals that we can use in things like ChatGPT. When we're working through an incident, we can actually put in the right questions and we can interpret the answers betterly. God, I'm a little tired, but let's just stick with it. Betterly is now a word. So let it be written. So let it be done. But we can do it better, right? We can do it better when working with the different tools, because here's the problem. The problem is complexity. If you're looking at IT and IT security specifically, the amount of change that we encounter in this industry, even within a year, is just astounding, right? Like as we're moving through, like right now, we're in the Windows 11 migration, which kind of sucks. I think that that's kind of crappy. But when we're looking at like cloud computing and we're looking at really what's going to be happening here in just a couple of, hours, with Amazon trying to deal with all these different things, is you're going to have a whole bunch of vendors. They're going to be coming up with products. They're going to be setting up automatic load balancing and auto scaling to prevent the problems from occurring that's happening right now today. And that just adds more complexity, because now you have another vendor, now you have another SaaS cloud service to deal with another part of your overall security infrastructure for the concept of availability. And it just keeps growing. So we need to be able to work with things like AI and work with automation. We absolutely have to, but it requires us to have a good understanding of what it is these different tools are providing for us. So you're in a great place, right? You're starting up in brand new security, core fundamentals, and none of these fundamentals are going to be outdated because of EDR. None of these core fundamentals are going to be outdated because of AI. These core fundamentals are going to become even more important as these tools take a larger and larger share of automation so that we can deal with technically complicated problems. Because there aren't really technically complicated problems. A technically complicated problem is a whole bunch of very, very simple problems knotted together. And if you can look at it that way and you can start applying the things you learn in these courses to your overall approach and your growth as a security professional, you're going to be in a much better place. All right, let's keep going. And that leads us to not panicking, right? Don't panic. Fun fact about this particular sign. Does anybody know what the history is of this sign? Where was this sign displayed? It says keep calm and carry on is what it originally said. What's the history on that? We have a lot of people typing on this. World War II in London. Somewhere in the UK, right? Turns out the signs were never, ever, ever displayed. They were never displayed. They were printed, but they were never displayed. And the reason why is they were printed in preparation for if the United Kingdom fell to Germany, then they would start putting out these signs, the ones that said keep calm and carry on. So I think that that's a little bit of interesting backstory. They were designed for Germany taking over the United Kingdom, at which point they would put them out. But this, kind of using a little bit of a joke, keep calm and no panic. Definitely, definitely panic. A lot of people, when they're dealing with incidents or they're dealing with hacks, they just jump into this ultimate panic mode, right? Telling people don't freak out, right? And the only way that you get to the point where you do not panic is through practice and training. You repeat and you do things again and again and again and again. And this is what is so important about the labs and the concept of this pay what you can model, and the fact that the labs are available to you once we get them back up and running, but the fact that the labs are available to you even after this course is over. Because I'm not a huge fan of classes that have lab infrastructure that only exists and only runs while you're taking the course, because that doesn't mean you can drill. It doesn't mean that you can get really, really good at the concepts associated with those labs. So what we're doing here is we're trying to give you an environment where you can read about these tools, learn about these tools, listen to me about these tools, and then actually get your hands dirty and start doing. And it doesn't matter if AWS is down. It doesn't matter if you get through it and you understand it 100% this week, right off the bat. The only thing that matters is that you can continue to drill and you can practice and you can do these things. And this absolutely feeds into the concepts of job hunting, right? A lot of you are either looking for jobs or you're in a current job and trying to get promoted. And I think all of those things are great. But if you understand these core fundamentals of what we're discussing, you're going to be in a great position for your job moving forward. All right. So we're going to start with networking. We're going to start with TCP/IP because it's a very good place to start. Have a quick drink of delicious low sodium V8. Low sodium V8, not sponsoring this class yet. I would totally put a patch on my jacket. That's good squishy. All right. So before we get too into this, I mentioned the concept of, TCP/IP has 4 layers. And I think of Star Trek, there are 4 lights. Got the sun right here. See, but I have a beam that blocks it. Yeah. So there are only 4 lights. But when we're looking at how people learn networking, a lot of people, I can't remember if it was 3 lights or 4, but it doesn't matter. It's just, Picard strapped to a chair and getting, beat up about the number of lights. Stupid Kardashians. All right. So before we get into networking, we have to unlearn some stuff real quick. The thing that we have to unlearn is the OSI model, the Open Systems Interconnect model. How many of you learned the OSI model or are learning the model in school, or you learned it in school, or you learned it from somebody? We got the OSI model. It's a great episode. Yep, you learned the OSI model. All right. So how would you feel? By the way, we should really reach out to the people at Network Plus and we should be like, hey, you need to stop teaching the OSI model. OSI model is garbage. Shouldn't teach it. Now, why do I have this thing against the OSI model? The first thing is the OSI model doesn't really exist. The OSI model was never really implemented in modern computing. There is a great article. There's a great article called The Internet That Wasn't. There we go. It's not even good in theory. So here we go. So here we've got this great article that talks about how the OSI model came about. And I'm going to give you a little bit of background on this. The OSI model was created by these dudes, also known as the whitest dudes you've ever seen in your entire life. You can just smell the cigarette smoke and brandy just emanating off of this photograph, right? And this is all the way back in the 60s. And they came up with this concept with the Open Systems Interconnect. And they were trying to talk about how computers would transfer data over a network and how it would actually work. And like I said, I want to say it started in 1964. Associated with it, I could get that wrong. It started at Berkeley. But no, it was all over the place. We're looking at ARPANET and things like that. But this article goes into a tremendous amount of detail in talking about how they tried to create the OSI model and then ultimately how the OSI model lost to the TCP/IP four-layer model. And a lot of people just try to correlate the two together. They basically are like, here's how you take the OSI model and then we tie it over to the TCP/IP model, right? And it's just really frustrating to me that we continue to teach it. And to be honest, I taught it, right? A lot of people were trained in it. A lot of, like, I know SANS, we would teach it, we talk about it. Please do not throw stale pizza away and all that stuff. And as I started digging more and more and more into the OSI model, and I started reading books, actually doing some history on it, I came to the conclusion that it was garbage, right? So if we look at OSI versus TCP, you see a lot of how these different models correlate back to each other. Right here's a good one, right? So we have the OSI model, right? And then we have the TCP model over here. We have network access, internet, transport, and application. Now, on the right-hand side, we're looking at network access, internet, transport, and application. That's how the internet works. Like, if you're looking at network access, data link, and physical, we're dealing with MAC address. And we'll talk more about Scapy here a little bit later, but we actually can create raw Ethernet frames that allow us to manipulate that network access. And then you can move up and you can deal with the IP header that goes to the internet side of it. And then you get to the transport header, and they pretty much map up very, very closely at that particular point. But then you get to application, all bets are off. TCP/IP wisely came to the conclusion that as soon as you get to the application layer, basically any developer of any application can do whatever the hell they want with that application and how that data is being transported. And in the OSI model, they got tied up in the application layer of having the session, presentation, and application layer. And that's really where everything fell apart. In fact, if you look at the last two layers, the application and the presentation layer, the reason why those two layers exist is because there was a huge argument back when they were creating these models. There was an argument between the United States, a bunch of academics, and people in Germany about what they should call the application layer. And I can't remember what the name of the company was, but some company in Germany, they referred to the equivalent of the application layer. They called it their presentation layer. And in the US, they called it the application layer, and they got into a geek fight. And the solution to the problem was to simply create two separate layers. So they basically created the presentation and the application layer. And that was that. That was their solution. That's not the way to do things, right? I mean, anytime you're dealing with a model that's built on consensus, it's going to just not make sense in many ways. So that is the OSI model, the internet that wasn't. So we're going to be teaching the TCP/IP model because that's how computers work, kids. And I talk about this because when I'm teaching networking and I have someone that has learned networking from a university or some other professor, or possibly even from me years ago, and they're constantly trying to put the OSI model in their head and it doesn't work because what they're seeing in Wireshark doesn't match. What they're seeing in TCP dump doesn't match. What they see in Scapy doesn't match. So they're constantly trying to find where this thing that they were trained applies in the real world, and they don't. So that's why we're focusing on the four-layer model for what we're doing here. And we're going to start with the IP header. We have the 802.2 header. We have the Ethernet frames. We don't get into that. You'll see it whenever we get to Scapy Lab on that. I still think Amazon is down. I don't know if anybody has done any tests on it. I still think the system is down. The system is down. Let's see what we got here. There we go. Request sent. I think we're still down though. Someone can confirm that for me. All right. So whenever we're dealing with the IP header, we're dealing with the header that actually has the basic core fundamental of getting started with sending packets from here to there. So I'm going to kind of I was planning on doing this live. I don't think I'm going to be able to do it live. Let me go here, go back to my labs directory, and let's start with Scapy right here. Kind of a breakdown of what the lab does. But in Scapy, whenever we create a very, very basic packet, this is what the very basic packet looks like. So when you're thinking of packets, you need to think of them as layers, like ogres and onions. They have layers, right? And you have this Ethernet frame, and we have the destination equals none. The source is set to all zeros. That is a MAC address, media access control address associated with it. And then with a type of the payload type is going to be IPv4, which I'm going to talk about more here in just a little bit. But when we're looking at that number, that 0000000000, that's a media access control address. And that particular address, I can't remember how many possible values there are for MAC addresses. Just to say that there's an infinite number, and we're going to be somewhat close to that, insofar as humans are concerned about it. But that media access control address is a MAC address, and every computer system in the world has a unique, quote unquote, and star, because we're going to come back to that, media access control address. Even this system, if I open up a terminal, right, and I do ifconfig, you can see that I have a bunch of adapters on this, and they have different media access control addresses associated with them. And the reason why they all have different hardware addresses, you can see right here, it's Ethernet. That ties back to Ethernet here. So like this particular address for my EN0 is 6635 5D 4F E8FD. All right. And I screwed up. It's not 6635. It's 6635. But two different numbers, but that's getting into hexadecimal. But that particular media access control address is unique to this adapter, and it's designed to be a globally unique address for that adapter. And that can actually be changed, right? We'll talk more a little bit about like ARP cache poisoning and things of that nature, but that can be changed. So whenever it's set here, dest is none, and the source is set to 0.0.0.0, tools like Scapy will automatically update that to the media access control address for the system. Now that frame never leaves the local switch. That's all local. Like if you're at home, that frame, that Ethernet frame, is not going to leave your local network in your house to your local wireless router. It basically is allowing your system to communicate with other systems on the network, right? So it's basically kept right here in my situation in my barn, right? And then we get into IP. Now, when we get into the IP header, we can change and modify anything. And we got the version, we've got the header link, the type of service, the link, the ID, any flags associated with packet fragmentation, TTL values. So let's go through and start breaking that down. So when we're looking at an IP header, the vast majority of the traffic that you're going to encounter is going to be version 4 or version 6. You will not see version 5. Version 5 was just an academic implementation as a bridge between IPv4 to IPv6. So it doesn't exist. But vast majority of what you see is going to be IPv4, and that's really what we are teaching here as well. On that as well. So we have the length, what is the overall header length, and then we get the type of service. This actually has been many times renamed to a differentiated service field, and that can do with prioritization. So if you're gaming on the internet, you can set a prioritization as far as like when the packets will get pushed through and how fast they will get pushed through. So a lot of gaming services will set that, I think, to 3 for getting it out, right? And not much happens if you do modify it. Like once it gets onto the internet, a tremendous number of routers on the internet are like, F you, kid. It's fine. Goodbye. Total length, just total length. And then we get into the identification field. Now that whole row, we have identification, we have X, we have the D and the M, and then the fragmentation offset. That whole row deals with packet fragmentation. So a long, long, long time ago, in a galaxy far, far, far away from Earth 2, we had routers. Now, what is a router? So if I were to take and do trace route. So let's do trace route. And I'm going to trace route to 8.8.8.8. Too many dots there. It's going to attempt to identify every routing hop between me and 8.8.8.8, which is Google's DNS server. Now I'm getting stars. When I'm getting stars, we'll talk more about trace routing and how it works. It means that second router is non-responsive. And this is the part where I'm worried that, do I have, give me a second. Never mind the man behind the curtain. I'm going to pause my screen sharing for just a second. Why? Because I think there's a possibility. I think there's a possibility that Cloudflare Warp is not being updated. SVPN, and there we go. And each of these routing hops that you see, 172.16.0.1 is the router in the corner. 10.10.98.1 is the wireless interface that boosts it up to the hunting shed that I have across the hill. 10.10.0.1 is the edge router for my network. And then we hand off to level 3 communications. This is in Minneapolis. That's our internet service provider. Then they do some stuff inside of Lumen, and then it pops out and it hits Google's DNS server. Each of these are routers. And all of these routers, they're kind of like post offices where they're moving our packets, our discrete data from router to router to router to get it to something like google.com. So if I ping 8.8.8.8, don't worry, we're going to do ping, I am sending packets to Google and it's responding, right? So I'm pinging 8.8.8.8 and it's responding, and it responds in 32 milliseconds or 30 milliseconds. So I sent 2 packets and I got them received. Now, every one of those packets went through all of these routing hops. Every one of those packets went through these routing hops because that's how my traffic gets to Google. If I were to do traceroute yahoo.com like that, it's going to go a different series of routes. The same ones right out of my house will be the same, but then I'm going to pop out into Chicago, and then I'm going to pop into Yahoo's infrastructure. All right. So I have, whenever I send traffic out on the internet, it's going to take a number of different routes and a number of different hops for it to actually get there, and it requires routers to get there. Now, how does that relate to packet fragmentation? Well, a long time ago in the early internet, the different routers that would route traffic on the internet, they could only deal with packets of certain sizes. And if a router couldn't handle that MTU of a certain size, the router would break the packet up so it could pass it through. Instead of just saying, nope, I can't fragment this, I can't do anything, make smaller packets, it would break it up and it would create new packets. So let's say a big packet, a jumbo packet is too big, has to break it up into 3 separate sections. It'll create 3 new packets, and then it will make every one of those packets will have the same IP ID. So that way the receiving system knows all those packets are kind of like a nice rug. It makes the room hang together. It knows that all of those packets work together. All right. Then we get into the flags. So if we have the don't fragment flag set, it tells that router not to fragment, and then the router will just respond back and say destination host unreachable. If it says M, it means more fragments are to come. So the first packet that it breaks up will have the same ID as the next 3, and it'll have the more fragment. That lets the end system know that there's more fragments to come. The second one will have the same IP ID, and it will have the more fragment bit set. The third one will have the same IP ID, but because it's the last one, it won't have that bit. So then the end system knows to start reassembling those packets together. Fragmentation offset is the offset from 0 of where these packets go together, how you stick them together. So let's say the first one is 1 to 100. The next one's offset will be 101. If that goes from 101 to 200, the next offset will be 100 or 202. So that's how we reassemble them. Now, the next thing I want to call out on this particular like little section that we have right here is the X. Now, you might be thinking that's out of order. It should be DMX. It's not, because that's where the bit goes. What is that X? Because X gonna give it to you. Gonna give it to you. X gonna give it to you. What is that X? Smithy J is typing. We got some people typing in. What is that X? Got a lot of people typing. Oh, they all stopped. Oh no. I love the paintings about it's always DNS. Yeah, it's the evil bit. I did do the evil bit. I did do the DMX reference. You got to give me credit on that, Black Sheep Mamba. I did do DMX, right? No, that is the evil bit. All right. So I want to show you something. If you look up evil bit RFC, this goes all the way back to 2003. It is a request for comment. All right. It was written by Steve Belvin. Now, this request for comment is one of the earlier ones. It was not written on a toilet. It's not even a rumor. It's been proven. The very first RFC, which was actually RFC 2, was actually written on a toilet. I can talk more about that, but at any rate. So this talks about what this bit is. And it talks about how this flag, it was a reserved bit. They didn't know what they were going to do. So that X means it's reserved. And Steve Belvin in 2003 said, you know what we need? We need this bit to be here, like we're going to call it the evil bit. So anytime anyone that's ever launching any attacks from this particular point, to solve this problem, we define a security flag known as the evil bit in the IPv4 header. Benign packets will have this set to 0, and those that are used to attack will have it set to 1. So it makes it a lot easier for people to detect these attacks. Now, how am I using this as a pedagogical technique? The RFCs define how the internet works. So if you're ever sitting around and you're like, how exactly does like IPv4 work? Well, that's called out in 792. How does the three-way handshake work? Well, that's 793. How does the internal non-routable, that'd be 1896, I think. I don't know, I can't remember exactly which one was I should know this. Like, why am I brain farting this? What is the RFC for non-routable IP addresses? It's just one of those days. Can't remember. Just brain fart. 1918. Thank you very much. I say it all the time. I teach it all the time. You think I would have that? I just totally, for some reason, I wanted it to be 1896. I don't know why, but yeah, RFC 1918 describes how internal non-routable IP addresses actually work. So all of these different rules are what define how things work on the internet. And I use the evil bit at this particular point in the class to show people how you can learn more about how the internet actually works on that as well. Yeah, I feel awful that I forgot it. All right, so we're now at the top of the hour. I try to take a break every 60 minutes. So with that, we're going to take a beat. We're going to take a 10-minute break. And when we come back, we're going to continue talking about the IP header. Back. All right. So, excuse me. I just realized I have no mail. I have this really nice card someone snuck to me from my class. It was really, really cool. A nice write-up saying thank you for Malware Attack Confessed. I'm not entirely certain, but I think that they came to my house, broke into my shop, and set it on my desk here in the barn, which is a little creepy. So it was a really touching card, but I'm pretty sure They broke in and set it on my desk. So touching, yet creepy. I prefer my stalkers to be happy and far away. All right. All right. By the way, the whole Meta CTF team is still working on this. I think, I don't know, Nicola, are you guys moving to a completely different region? Is that where you guys are headed right now? Because it still seems like the internal IP address networking stuff is completely boinked for Amazon at the moment. So, but no, they're doing it. They're doing it. Yeah. Be surprised if it's CrowdStrike again. I don't even know about the FBI oopsie story. I've been teaching, so we'll do that. All right, so we got done with fragmentation. We get to time to live. So this is going back to trace route right here. Whenever we do a trace route to like 8.8.8.8, this is kind of interesting. Every single packet has a date of expiration. And that changes based on the operating system, which I'll get to here in a couple of seconds. Now, a long time ago, the original TTL was actually a timer, which is kind of weird. I never saw any like write-ups or screen or pictures of what it actually looked like. But originally in the kind of the initial phase of the internet, it was a timer. Turns out it doesn't work real well because time is an incredibly subjective critter, right? Like, you know, I'm in Mountain Time. We have people in Eastern Time. We have time traveling nerd herder who is here from Tuesday. Hey, Brian, I think it's Tuesday where you're at. Is it Tuesday morning? We know it's not Tuesday afternoon. Yeah, time is a weird thing. It's all over the place. Like we got some people here, it's 6:13 a.m. There we go. It's all kinds of weird time zone shenanigans. So instead of it actually being a time value, they made it a reverse counter. So it counted backwards. So you would start out with the value, and then that value would be decremented for each router that it goes through. So if we look at, if I do ping 127.0.0.1, like that, you can see my TTL is 64. That is the starting TTL for for a Mac. It's also the same TTL value for a Linux system. It's also the same TTL for a BSD system. Ha! Joke. They all use the same TCP stack. Mac, BSD, and Linux, they all started with the same NetBSD TCP stack. So they all had the TTL value of 64. All right. Now, on a Windows system, it's 128. On a Solaris system, it's 256. Cisco iOS is 256. You have all these different operating systems that have different starting TTL values. So when they put that packet out on the internet, every time it routes, it decrements that packet's TTL value by 1. So it'll hit this first router, it'll be 64, then 63, then 62, then 61, then 60, 59, 58. Something happens here where it's not responsive. That's what the stars mean. That'll be 57, and then it'll hit the dns.google.com, and it should be 56. So if we look at our, and by the way, there's weird things that happen between those things. So if I do trace route to Google, we can see that the TTL value is 117. For whatever reason, that's telling me it's probably starting at 128 and it's decrementing back from there. It's about 11 hops between here and there. So does that make sense to everybody? I want to make sure that everyone understands that TTL value is a reverse counter, right? It's a reverse counter. When the packet gets put out on the internet, as it gets routed, every single router will decrement it by 1 before it passes it on through. So does that make sense? Can I get thumbs up in Zoom or something? I think we're good. All right, we're good. All right, very, very, very cool. I'm a little bit disappointed that Zoom doesn't have a thumbs down feature. I think that would give proper motivation to anybody that's presenting. You get the thumbs up, you get that warm feeling. It would be like kind of an InfoSec American Idol. It'd be like, oh, I'm now going to be talking about the OSI model. And people would be like, thumbs down, thumbs down, thumbs down. Oh, I don't know what's going on. I need that constant affirmation on it as well. We have the protocol, which is the protocol, and then the checksum. Now, that checksum is not meant to be really robust checksum. It's more of like a CRC32 value checksum where it's just done very quickly. And the integrity of the whole thing is built around the internet was built by ARPA and DARPA. Was first released in I think it's 1212 or 1717 Connecticut Avenue in Washington, D.C. at the Hilton there. But there's a great ballroom. Like, let me show you real quick. This is like one of those things. How do you spell Connecticut? Right here. That's not it. So, okay, so this is kind of funny. This picture right here. That's not it. Let me go here. Right here. So this ballroom, there's a couple of different things that are pretty cool about this ballroom. So this particular ballroom is the main ballroom that's underneath the Hilton in Washington, D.C. I think it's 1212 or 1919 Connecticut Avenue. It looks like a spaceship. It is so cool. Like you can have all kinds of cool lights and things like that. And very, very, very neat, beautiful ballroom. And a couple of historical things. First, like I said, the internet in its first iteration was released there. So a lot of what we're talking about was released at this particular ballroom in Washington, D.C. The other thing is Janis Joplin, Jimi Hendrix, and the Doors all played in this ballroom. And the final thing is it's a minor thing. It's a minor thing compared to all of those, but I've actually taught in this ballroom. When I was teaching for the SANS Institute, I taught SANS 504 in this ballroom, which was really super wicked cool, right? So we had that checksum. Now, what the hell does this have to do with DARPA and all that stuff I just said from a historical perspective? Well, whenever DARPA and ARPA was creating the internet, they were very, very, very concerned about the impact of radiation on the on packets that were traversing across the United States. If you had thermonuclear war, which is bad, that could create radiation and that could cause degradation of packets. And if you have a checksum that doesn't match what it should be, then you discard that packet as though it never existed. Now, you don't respond with a reset, you don't respond with anything. You just pretend that packet never hit you and you move on with your life. Source address and destination address, those are our IP addresses, right? So you've seen me going through and pinging systems right here, where I ping 8.8.8.8. That is an IP address that's owned by Google, right? So we have these IP addresses that exist. And the best way to think of an IP address, if you want to, is from like a mnemonic device, is think of them in terms of like phone numbers, right? Like you have a phone number, and that phone number is what you would dial up. So like my phone number for my school growing up was 605-348-1477. That was the grade school that I went to. And I memorized that phone number because I would walk to school. Not joking. I think it was about 2.5 miles. I would walk to school, and I was told if anything ever happened, I could go to someone's house and I could ring up the school and let them know what happened or something along that nature, or whatever. But that was, and also my mom worked there in food service. So I memorized that phone number, and that's the number associated with that school. Now, the problem is I went to St. Elizabeth Seton, right? As it is today, people would just Google St. Elizabeth Seton and then call that particular number. So what we do is I can put in a number. I can also put in a fully qualified domain name like www.yahoo.com, right? And it's automatically going to resolve that name into a number. And that's done through DNS. You've seen a number of people joking, it's not DNS, it's always DNS. It was DNS, right? Like these different joke memes that it's always DNS. DNS is what resolves these names into numbers. It is a service that does that automatically for your computer system. Because if you're looking at how packets work, computer has no idea, none whatsoever at all, like what www.yahoo.com is. Just none. Just doesn't have any clue what that is. So it has to use DNS to resolve it into a number. Once it's converted into a number, then your system will start sending the packets to that remote computer system, because memorizing numbers is hard. So we have the source address and destination address. So let's talk a little bit about how this structure is laid out. If you notice, the source address goes all the way across, goes from the left to the right. Destination, left to the right, all the way. Identification only goes halfway through. All right. So the source address is a full 32 bits. If I was to go through the effort of trying to count each one of these little bits, it would equal 32. So source address is a 32-bit number. Destination address is also a 32-bit number. That means there's roughly 4.72 billion and change possible values for source and destination address. Identification is only 16 bits. That means there's 65,536. You go cut that in half and you got 256 possible values and so on, right? So when you're looking at the values that exist in the TCP IP header, you can get a rough idea of what is the total size in bits by quickly looking at this chart and seeing how long the different values are on there as well. All right, so now I mentioned when you're using Scapy, here we go. When you're using Scapy, you stack your packets, right? So we have the TCP IP header, we have the IP, and then we have UDP as well. You can also have it broken down by TCP. We'll talk about UDP here in just a second, but they're stacked. So above this IP header, there would be the Ethernet, then there would be IP, then there would be a TCP or UDP, and then the application specific header for that stacked packet that we are building on that as well. So they literally stack on top of each other exactly like Legos. So we're just stacking them up. So we're going to look at TCP first because we have TCP and UDP as two separate protocols that we can use underneath IP. Now we have the source and destination ports. A port is a specific number that your computer system can listen on. It's a port of communication. So if I go back to, we're just kind of messing around with Google a little bit today, and that seems like fun. I can do nmap and I can do 8.8.8.8, and I can see what ports are open for communication on that. And I think it's going to be 8053 and it's going to be 443 in just a couple of minutes, unless Google is blocking. There we go. Should come up. It saw that that host was available. It's first pinging it. Now it's going to attempt to identify what ports are open on that particular computer system as well. So it's just running a little bit slow. 18 seconds remaining. I should have became root. Maybe I could do that. Do that. See if we can run a little bit faster. All right. Now I'm just going to give it a handful of ports. We're going to do check on port 80 on 8.8.8.8. It's going to come back here in just a second. It's going to say it's filtered. We can change it to 443 like that. And it's going to say it's open, right? So there's a number of different services that can exist on your computer system. And those services are basically tied to different ports. This is a DNS server. So we should see that that is open, which is weird because it's actually TCP 53, which we can talk about more a little bit later on that. My password is clearly John123. You got me, right? You got me. So we can see what ports are available. Now, different ports have different services associated with them. So when I'm surfing the internet, I'm generally surfing the internet on port 443, right? So if I were to open up a browser and I were to go to DNS, let's just go to let's go HTTPS, because that's the port associated with it, // and then I can just put in 8.8.8.8 and it's going to become Google. And it's going to say, here's the public DNS website for Google. See, that's just a web service that's running on it. I can use NSLOOKUP or dig against that server to look up additional services as well. So there's a number of different services that exist when you're communicating out on the internet. We're going to talk about that more when we get to Shodan here in just a little bit. But we can see those ports. So every time you send a packet, you notice that there was a source IP address and a destination IP address. There's a source port and a destination port. And the reason why we have these is so that the systems know how to respond. Because when we're communicating, it's flipping it every response. So my destination port will be 443 and then it'll flip it to what the source port was. And the source port is usually a randomized port coming from my computer system as well. Now we get into these sequence numbers and acknowledgement numbers, and this is a 32-bit number to maintain the integrity between the communication between this system and that system. Now, the other thing about sequence numbers that's super duper duper important is keeping all of the communications separate from each other. I want you to think of like Google, right? If I go back to Google, how many people do you think are using Google right now? There's a website that has that. Let's look at that. I do. How many people are using Google at any point right now? There's hundreds of millions of people that are using Google at any time. Google does 9.5 million searches per minute. So if we look at that, right? And I have a port that's communicating to Google, and I'm here in South Dakota, and somebody else is in Kazakhstan, is nice, right? How does Google keep those communications separate? It actually does a number of things. We'll talk about session identifiers in the intro to security class, but one of the things that it does is it uses that sequence and acknowledgement number and IP address to keep all of these conversations from a TCP/IP stack perspective separate and distinct from each other. So anytime we open up a connection, we start with the sequence number that is like 4.72 billion possible values. And then when that system responds, it acknowledges it by incrementing it by 1. So we now have a number that is uniquely syncing us communicating with each other. But when it also acknowledges, it starts with a brand new sequence number. So it sends one sequence number, it responds back with an acknowledgement number, and then it starts a new sequence number. And then we communicate through a series of ACK packets where we increment the acknowledgement number by the number of bytes received. That's pretty cool. So it allows us to start with a random or pseudo-random number. It allows us to keep all of the communications separate, and it allows us to not have any collisions of data. It's really a super elegant solution for data transfer on the internet as well. So as we like to say, we start with, we'll do the three-way handshake here in just a little bit, getting into a little bit more detail on those sequence numbers and acknowledgement numbers. Okay. All right. Then down here, we've got some more offset values. We've got some reserved values. And then we get into these TCP/IP flags. The first two are utilized for congestion, explicit congestion notification whenever the network is getting congested. All right. But then we get to the really important flags. UAPRSF. That's urgent, ACK, push, reset, SYN, and FIN. Urgent means there's some urgent data within the payload. As soon as the urge flag is set, the urgent pointer should be set as well, and it should give you an offset where in that payload the important data begins. ACK is just associated with the acknowledgement number. Push means don't fill up the window size right here. Don't fill up the TCP buffer, send it directly into the application. Usually the window size is how much data will be received by the receiving system before it takes the data off the TCP/IP stack and flushes it to the application. So whenever we say push, it says ignore that, send it right in. Reset means reset the connection. There's been some problem with the numbering. We just need to start over. And SYN means sequence number. That means we're starting a connection. And then FIN means it's the end of the connection, FIN, right? And we talked about window size. Checksum is another checksum. We have a checksum for IP, but we also have a checksum for the TCP header as well. And then the urgent pointer. We also have various TCP/IP options that we can use as well. UDP header. So you don't really have the both stacked on top of each other unless there's some type of like encapsulation, tunneling, or encryption being utilized, something like VPN. But when we're looking at the UDP header, usually it's separate from the TCP header. It does one or the other. If you really want to make sure that the communication is going to get there, the packets are going to be received, they're going to be received in order, they're going to get reassembled in order, everything's going to be good, you're going to be sending it via TCP/IP. If you want to send it fast and you truly do not care how fast it gets there, you don't care much about sequence, you're going to use UDP, or user datagram protocol. Now, UDP, as we sometimes joke, is the unreliable DAM protocol. And notice that there's no sequence, there's no acknowledgement. It's just straight source, destination, length, checksum, go. As we say, it is truly a fire and forget protocol when you're utilizing UDP. Now, another problem with UDP, it's actually not a problem, but like what would be the application of UDP? What would be a service that you would want to send packets as fast as you can, and you really don't care if they all get there? Voice over IP and streaming video, right? You're just going to send it and forget it. You don't care. If you drop a few, there may be a slight glitch, but it's going to just pop out there. And it's going to make it to where it needs to go. So that's where speed is more important than having integrity. And TCP is when integrity is more important than speed. As we see the Canadian guy, gonna send it, right? All right, UDP header. Now I mentioned the TCP IP three-way handshake. We talked about the SYN, SYNAC, ACK established, right? So whenever I send packets, I don't think I have, hold on a second. Okay, cool. Let me see if I got the right version. There we go. Do that. I don't know if I have TCP dump installed. I do. Awesome. All right. So here's what we're going to do. We're going to show you some packets. I'm going to open up some more here. All right. So I'm going to open up a Netcat listener on port 2222 on my system. Now, on another terminal, I'm going to go netcat 127.0.0.1 on port 2222, and I can send data back and forth between this terminal and this terminal. So I can do hi, send it. It says hi there. I can go hello back. Right? And I can do hello me. It's me again. Right? And I can send data back and forth between these two windows, right? You can see that they're communicating, just communicating back and forth. Okay. So what we want to do now is let's sniff that traffic. Normally I would do this in the VMs that we're sending. We would do it within the VM. So I'm just going to do it within my system. I'm going to kill that connection between the two that we have. And then I'm going to start a sniffer over here. And I'm going to listen on the, I'm going to listen right here. Where is my, I don't know. What is the local loopback? Did they change that? Was it EN0? It's too many damn adapters on a Mac. LO0. That's what they renamed it. There we go. All right. So we've got that listening on this, and we can see that we have some communication going back and forth. So I'm going to start listening on port 2222, and I'm going to make that connection. And down here, you can see that we're making that connection back and forth between these two ports. You can see that we have these flags that are being set in the traffic going back and forth between these two. Now, right here, you can see that we have, this is a SYN flag right here. And you can see the sequence number is 122949114. And then we have an acknowledgement of 24578. That's a 32-bit number associated with it. Now, with that flag, if we look at that acknowledgement number, you can see this acknowledgement number right here, this 24578. You see that that matches here and this one? You see how these two match right here? Notice that they're different, though. Notice that whenever I started my first sequence number, I gave just a sequence number and no acknowledgement number. And then when that port responded, it responded by incrementing that port by 1, right? And then it created a brand new sequence number. So it starts with a randomized sequence number. That's your SYN right here. This is our SYN sequence number. And then we respond back with a SYN ACK. We have the sequence number, and then we have the acknowledgement number, right? But it starts a brand new sequence number. Whenever it acknowledges that previous sequence number right here, let's see if I can make this a little bit bigger so we can see it a little bit cleaner. Here we go. When we take that sequence number and we acknowledge that sequence number, we increment it by 1, and then we're done with it at that point. That's just proven. It's like, yeah, I know I'm talking with you. You're talking with me. Here's me acknowledging that sequence number by incrementing it by 1. But after that, we start a brand new sequence number. And then that sequence number is going to increase by the number of bytes received. So we start with the SYN. That is that first sequence number. We acknowledge that sequence number. We acknowledge that sequence number. Let me draw here. There we go. These two are associated with each other. And this acknowledgement number is just a +1 on that sequence number. And then we start a brand new sequence number. And every acknowledgement number is going to be incremented. The first one's going to be incremented by 1, but after that, it's going to be incremented by the number of bytes received from that communication for the previous packet. So that's a way that our systems can communicate. So we have a SYN, SYN-ACK, and an ACK. And then it communicates after that point with a series of ACKs. It goes ACK, 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 ACK. I see you guys all talking about Mars attacks, all right? I am convinced that Tim Burton's classic Mars Attacks is an in-depth introspection on the TCP/IP three-way handshake. Somewhere on the cutting room floor, there's a scene where a baby Martian is born, looks up at its mother and says, SYN. Its mom says, SYN-ACK. Communicates through a series of ACKs until the day it dies, at which point it says FIN. But we never saw that because his head exploded. Once again, too messy, probably for the best that Tim Burton cut that from the film, to be completely honest with you. All right, so that is the TCP/IP three-way handshake. Let's talk a little bit about ports and what ports are and which are the main ports that one should be very, very, very familiar with. I'm trying to figure out what the hell's going on with my phone. Break through walls. I can't get a phone to work. Okay. All right. So if we look according to insecure.org, which is the people behind Nmap, rather the person, Fyodor Gordon, is the main developer of Nmap. Nmap is the de facto port scanner on the internet. It is by far and away the de facto port scanner. And I honestly can't name other port scanners. I mean, you have Masscan, AMAP, you have some other things, but as far as like a dedicated port scanner that competes with Nmap, not so much. A lot of the other port scanners have very specific use cases in what they're actually doing with it. And according to Fyodor, these are the top 10 ports that are seen by Nmap. All right. You have 80, which is web traffic, unencrypted. Telnet, 23. 22 is SSH, right? We see encrypted SSH traffic. And then we have HTTPS, which is encrypted web traffic. Terminal services on 3389. Microsoft Data Services on port 445, 139, 135 would be like RPC, SSN traffic. And then we have FTP and SMTP. So when you're getting started in computer security, these would be the main ports that you'd want to focus on learning, right? You would want to really understand how these ports and protocols work. You don't want to get into a bunch of other weird ports and protocols just because it gets too much. Like I don't even memorize all of the different ports and services that you encounter. A lot of what you encounter as a pen tester is new ports and services you've never seen before. You investigate them, you do bad things to those ports and services, and then you move on to the next test. And hopefully, if you're lucky, you will remember what that is later. That is so weird. I don't know why. It's very, very, very strange. All right. So yeah, my phone's not acting right. It's almost like there's something going on. And then we get Samson that talks about 4444, which is the default port for Samson. What is it? What is the default port for? Got a lot of people coming in. Yeah, it's the default port for Metasploit, right? So that's pretty cool. All right. So now, that's all the ports. Nmap is doing port scanning across the board, millions of systems a day, easily. What about just internet-facing ports? Well, if we look at just internet-facing ports, we're going to see different ports from something like Shodan, right? And let's go ahead and let's go here and let's play around with Shodan a little bit. Right? So Shodan is a service that allows you to query the internet in such a way they're crawling it constantly. And instead of where Google is crawling the internet and it's keeping track of like what the actual text of a website is, Shodan is doing banner grabbing, right? So if I were to do SCADA, you can see that there's a SCADA FTP server right here. This one's in Bulgaria. We've got this one is in Singapore. This one's actually a honeypot, right? And they can identify that it's a honeypot based on the header information because it's a known honeypot fingerprint for it as well. Actually, a lot of the SCADA systems are honeypots on the internet. But what about other services, right? So let's say I do a lookup for JetDirect. So if I do JetDirect, what is JetDirect? Anyone know? It's one of my least favorite things in the entire world. It's a printer. So there are 3,217 JetDirect printers plugged directly into the internet. That means you can literally send just random files to get printed to these JetDirect printers. Now, a long time ago, Russia was number one. If you looked at all the JetDirect printers that were connected to the overall internet, Russia by far and away was the winner. And then a weird thing happened, Ukraine war. And when the Ukrainian war broke out, remember firewalls in Russia were trying to filter out any news of what was happening in Ukraine and how really like incredibly bad the war was going, the one that was supposed to be done in 48 hours. I mean, generals were making dinner reservations in Kiev. Like, that's presumptuous, right? Turns out it didn't work out that well. Still hasn't worked out that well. It's kind of weird. It's funny. My display on the other side of my wall is now showing sunflowers. That's serendipitous. But all of a sudden, all across Russia, a bunch of JetDirect printers started printing out pages of news about what was really happening in Ukraine. And then a bunch of those JetDirect printers got taken offline. All right, we can do some other ones. Let's look for specific databases. So I can do Mongo database like that. Mongo database, we've got a whole bunch of different things. And by the way, this also gives you the capability to tell you it's a database, which is great. But then it also says it's an end-of-life product, which means it's now unpatched. So there's a bunch of Mongo databases that aren't being patched and up to date. That's pretty bad. But we can also do some additional like fun things. We can also look at images. Now, by the way, I'm doing a live demo at this point. I'm doing a live demo and there may be bad things that happen during my live demo. I'm sorry. It does happen from time to time. So these are all the different types of webcams and different RDP systems that are just connected to the internet with no authentication whatsoever. Okay, that's kind of neat. But I can also do searches for specific ports. Like I do port 5900, right? 5900 is a port associated with VNC. Oh, it's getting close to it's weird. We're not going to lie, right? At this point, we're getting a little weird. We got some goats, some goat love, some goat affection on someone's desktop at this particular point. By the way, years ago, I was at a conference. I want to say it was in Minneapolis, St. Paul. It was B-Sides, Minneapolis, St. Paul. And we were doing this conference at the exact same time as a furry conference in Minneapolis, St. Paul. And a bunch of people in IT security were like, haha, let's go make fun of furries. Let's go look at the furry conference because furry conferences are for geeks. We went to the furry conference and we discovered there were more women at the furry conference than there was at an information security conference. So one probably shouldn't be making fun of the furries, right? Because they seem to have their crap together a little bit better than InfoSec at that point. Then the other conference that I had that was at technically before was a GI Joe conference. Same situation. Wanted to go make fun of all the people that were into GI Joe. It was about 50-50. One of the proudest things that has ever happened for me at any of the conferences that we have ever done at Black Hills Information Security, Wild West Hacking Fest, whether we're doing it Mile High or we're doing it in Deadwood, is the fact that there is a line for women to get into the bathroom. And that never, ever happens at IT security conferences. So very happy with that, that we actually had that. So other than this goat furry thing that we have here, is there anything else that strikes you as a bit odd, a bit strange on the screen? See, we have this ICS. That's not good. If I were to, just give me a second, I got to do something here. Do that, do this, do this. Two shakes of a lamb's tail here, everybody. Erica. So, all right. So you see this ICS thing? Just for the record, you probably shouldn't see things that are ICS on the open internet. Does anybody know what ICS stands for? Go ahead and type it in Discord. What is ICS? Yeah, industrial control systems. These are industrial control systems that are connected directly to the internet. They control things like pump stations. They control water processing systems. I don't know. This one says manual principal distribution. I don't know. It's in the live shop. I don't know what that is. But this is generally bad. Like you wouldn't want to see this. By the way, this one that says float switch system healthy. I don't know. I think Shodan just added in a new service that they were looking for. But these are things that should not exist, right, on the internet. We should not see industrial control systems directly connected to the internet where anyone can jump in and literally take over. There's no authentication from this whatsoever. Could they also be honeypots disguised as industrial control systems? Possibly, although that's fairly rare. The vast majority of what you see for systems that are connected directly to the internet that have little to no security on them are not so much honeypots as they are like real honest to God systems that are directly connected to the internet. So this is kind of scary. And by the way, if you do this, let me go back to the Mongo database. Let me go to Shodan. Let's go to straight Shodan. And I do that Mongo database. I can add in a tag compromised. Shodan actually restricts certain tags that you have to pay an enterprise license for. So everything I'm showing you, just so you know, is stuff that Shodan's okay with. There are other things that Shodan has that they feel a little less okay sharing with people publicly as well. So whenever we're talking about ports and services, do you have a better understanding of when we look at a port like 5900, it's VNC, 80 is a web server, 443 is an encrypted web server? Is everyone feeling more comfortable with the idea of a service and a port? I just want to make sure that we're in a good place here. I still don't think that Shodan, not Shodan, I still think that we're down and out on. Has anybody checked AWS so far? Oh, there we go. We got an update from Amazon. Our mitigations to resolve launch failures for new EC2 instances are progressing, and the internal subsystems of EC2 are now showing early signs of recovery in a few availability zones in the East region. We are applying mitigations to the remaining AZs or availability zones, at which point we expect launch errors and network connectivity issues to subside. And that was about, what is that? About an hour ago. So they're still down. So it's okay. Like I said, the labs are still available for absolutely everyone to play with. All right. So those are ports. So how do we interact with those ports? Like, how do we like get our hands dirty and do fun stuff with those ports? So yeah, Somebody just posted a meme. Shit's on fire, yo. It turns out Amazon at 6 o'clock this morning saying everything's fine here, nothing to see, carry on, was a bit premature on that as well. At this point, maybe Jeff Bezos is getting a notification on his yacht of some bad things. All right. So Scapy is a tool that is designed to create packets from scratch, okay? From the data link layer all the way up to the application protocols by stacking them as Python objects. If we go back to the lab that we would normally be doing at this point, this is an example of what a stacked packet looks like. Oh no. That could be bad. Is GitHub down now too? Yeah, there we go. We got some panicking. We got some panicking if GitHub goes down, right? Like it's all fine until GitHub goes down. But you can see this is how we stack a packet. We have the IP header, we have the UDP header, we have the DNS header because that's the application level specific header for it, right? So we can stack these things. Now, Scapy allows us to take any of that header value and it allows us to change and modify or even fuzz different values on the fly. So you can see the IP header is version 4. We have no differentiated services length, differentiated services value. The type of service is just set to 0. Length is set to none. IP ID is 1, no flags, no fragmentation, TTL is 64. We can modify any of those values that we choose to. So we can take Scapy and we can create those different packets on the fly. It also has the ability for us to send and receive packets, right? So we can drop a packet on the wire and then we can get that response back and then Scapy can show us that response. Sniff has full sniffing capability is not the same thing as like a full TCP dump. You know, when I was playing with TCP dump, it was dynamic and interactive. It's not quite like that, but it's basically something that you can incorporate into a Python script that allows you to sniff that packet. You can read full PCAPs and you can write data out to packet capture files as well. And because it has a lot of different protocols built into it, so you can see this is a full DNS packet and all the different header fields for DNS. It's available to you to change any one of those different things, and that's pretty cool. But it also has a bunch of those protocols built in. So you don't have to build that section by section by section. It starts with the default template for you to work with. So you can see all the different types of different templates that exist. So here's an example. If you want to look at some default templates, I don't want to mess with this too much because like I said, oh, that is not good. That is so not good. Looks like GitHub shit the bed. So these are just like some of the A protocols. We have AD and, or those are different functions. We have ARP. So it can identify address resolution protocol, ASN 1P integer. We have ASN packets, ATT error response. These are just a handful of the A's of the different types of payloads and services that are built into Scapy that will allow you to decode and understand what they're actually doing. So what do we use Scapy for? Well, we can use it for a variety of different things, right? We can use it to test intrusion detection and intrusion prevention systems. Let's say that you have a signature that you're writing for Saracata or you're writing it for Snort, and you want to verify that that signature fires when a certain string or a certain type of condition exists. Well, this allows you to create that packet by hand or even programmatically within Python to allow you to test that rule to make sure it works. I'm going to be taking a break here in 5 minutes, hon. So it allows you to create that rule and test and validate that rule as well. That's awesome. You can replay attack or you can do traces to validate your detection logic. This is one of those things that we work on in our security operations center at Black Hills Information Security. Not just having signatures, not just having rules, but having the ability for us to validate and test those rules dynamically and make sure that they are in fact firing. Anytime you write any code, you always start with a test case that fails and then you write your code until that test case succeeds as well. So you can do that type of low-level analysis to do checking to make sure that your security tools are actually working appropriately. You can do things like packet level forensics. If you received an attack, you can load that attack up into Scapy, and then you can start analyzing it packet by packet by packet as well. You can also use it as traffic generation. We use it to generate malicious attacks, of course, with full permission from our customers whenever we're testing organizations. Because once again, if we're working in Python, Scapy gives us a full library that gives us full packet creation capability from the ground level to create and generate attack packets on the fly. So this is an example of someone setting up a very, very basic Scapy script. From Scapy, all import TCP and IP. So we're going to import the two header values for that. So I can create a packet, and then I can just modify the fields that are interesting. I don't have to create every field from scratch. So if you look at it, if I go back here, if we look at the IP header right here, if you notice, the IP header, I have version, differentiated services field, ID, flags, but at the bottom I have source and destination. I can modify any one of those. However, in Scapy, if I choose to, I can just edit one of them. So here I can say my packet equals IP header, dest equals 8.8.8.8. You can see dest is a value here, where we can change that default from 127.0.0.1 to a dest of 8.8.8. And then TCP, I can modify it to just modify the one field of the D port, which is destination port, to 80. And then I can go print before build. I want you to take our packet and I want you to build the checksum for the IP. And then I want to do the same thing after it's built to check that checksum. That's dynamically creating those values, those CRC32 values, to make sure that the packet is a valid packet, right? So that's just a quick, dirty example of a Scapy script where we're creating and sending a packet and putting it on the wire, working within Python, right? So if we ever want to look at a packet, we can do p show. That would be packet show. Oops, there's Logan calling. Packet show, and then I can see the summary, and I can look at what is just the TCP value, or I can look at a raw hex dump of that packet. So there's a number of ways to show that exact same packet in a variety of different formats. Now, as I mentioned, Scapy has a large number of different protocols, right? We have the link layer protocol where we have Ethernet, where we can do source destination with those media access control addresses right here. See that 0:00:00:00:00:00. That's a media access control address or MAC address. And we can change the source, the destination, the type. We can send it to the Ethernet frames. We can do tagging, you name it, we can do it. ARP, we have fields like the hardware source, the source, the destination. We can actually do full ARP cache poisoning using Scapy as well. So almost any of the fields and any of the values that you want to, you can modify utilizing Scapy. Now, at this point, we would do a lab. Instead, what we're going to do is we're going to take a 10-minute break. And when we come back, I'm going to walk through what the Scapy lab looks like. So when we get Amazon back up and running, we're ready to go. So we can start doing these labs. So now we have one lab that we are now doing on Thursday that we will do at the end of class at that session. All right, let's take a quick 10-minute break. We'll resume in just a little bit.
You're muted.
It didn't click all the way through. People are asking for the soundtrack. We will get you all a link to Daft Hack and that soundtrack. So how are we sitting? We still down? I think we're still down. I haven't gotten anything. I know Jesse's here, but yeah, there's the link, no bandwidth. All right. So this is the lab we would be doing. Let me post this into Discord real quick. There we go. And this first lab is really trying to get people set up with understanding how packets work by creating a packet a number of packets actually. And Cold Brew just confirmed that AWS is still down. So thank you very much, Cold Brew, for checking that out. So in this lab, you're going to learn how to create an IP packet. You're going to create TCP packets. You're going to see how it sniffs and it goes back and forth between them. So it's really, really cool. And the number of different things that you can do with Scapy. So when you start, you would log in and you would access your Kali terminal. So whenever you log in, you would basically access the server 2022. You would click on the Kali terminal, and then you would become root, right? And the reason why you have to become root, and we haven't gotten to Linux yet at this particular point, but the reason you would become root is because the Scapy is actually manipulating packets at a very low level, at the raw socket level. There are certain ports that you can't access, like 1026 or 1096 and below. You can't access unless you're root. So if you want to create any packets that are listening on port 80, you're going to need to be root. If you want to sniff the responses coming back from your packets, you have to be root. So that's why we become root to run Scapy. And I do pronounce it differently, Scapy and Scapy. I just go back and forth. Um, the reason why is in the industry, some people call it Scapy, some people call it Scapy, and I just somehow jump back and forth, which is really just proves that I'm probably borderline schizophrenic, maybe not even borderline, right? So we fire up Scapy and then we start building up the raw packet. So like right here, which I would click on it if I could. I don't think my Zoom works in Zoom. Nope, it doesn't. Here I am trying to zoom in for you all. Normally I would click on this and it would open up another link. Oh, there it is. Yay! Apparently that's working in GitHub. So we've already talked about this one quite a bit, but we have the packet whenever we generate it, we do mypacket.show, and it's going to show us the packet. And the packet is really just an absolute bare bones minimum packet, right? We have that MAC address, that media access control address, and that address, we got IPv4, and then all of the IPv4 header information that we can modify within Scapy. So there we go. Oh, I'm feeling better about life already, everybody. We're not getting these private errors anymore. That's good. All right. So now if we want to create a ping packet, we're creating a raw packet where we do my packet equals ether and then slash IP. We're stacking that ether frame on top of the IP frame, and then we can look at that packet with mypacket.show. We can now modify those values. You can see that the IP dest right here, we change that from 127.0.0.1 to become www.blackhillsinfosec.com, and then we tack on ICMP, which is a protocol. So we're sending a ping packet. And we're not modifying any of the default values of ping at all. We're just going to stick with it because it's a standard ICMP echo request is the default whenever we create an ICMP packet. So we're doing send and receive. That's the SR. That's what that means. We're changing in the IP header, the dest value is now going to equal www.blackhillsinfosec.com, and then we're going to tack the ICMP header on that. And then it's going to send the packets and it's going to receive. Now, it says it received 5 packets. Whenever the sniffer runs, it's going to be sniffing all kinds of packets, but there's only one packet of those 5 that is the answer. All right. So we just do a simple send and receive to send a ping to blackhillsinfosec.com. Now we can do a port scan on port 80. We can do send and receive the IP header, dest. We're going to change that to be 45, 33, 32, 156. And we're going to send that with the TCP header, where we're just going to modify the D port value to 80. And then the flags are going to be a SYN packet. So we're going to send a SYN packet to that system. Does anyone know what that IP address is? 4533. Let's take a look. All right. Here we go. I believe it is right there. So this website is scanme.nmap.org. So scanme.nmap.org is a target IP address that is designed to be scanned. It has lots and lots and lots of ports and services on it. So if I do nmap against that particular scanme.nmap.org, it's going to bring back tons of ports and services. It might take a little while for it to come through, but that's what we're scanning. So if you're looking for something that you can scan out on the open internet, this is a site that is designed for you to scan it. So I can even do some additional things. I can do like, let's do, let's just do an A scan. Everything in the kitchen sink. Like when you do an A scan, it's going to do operating system. It's going to do trace routing. It's going to identify the services. It's going to do a bunch of things against that system. And as you can see, Nmap's a lot easier, right? Nmap's a lot easier than using Scapy to create packets. So we'll come back. We're going to let that bake for a little bit and we'll come back to it. All right, then we can look at a range of ports by putting in a comma. So we can do answered and unanswered, send and received. The IP address equals the destination. IP destination equals, we're just modifying the IP header, the destination value. And we're going to put in the scanme.nmap.org IP address. We're going to put in the ports are 1, 100. That means we're going to scan a range. We're going to go from 1 to 100 with a SYN packet, and we're going to give it a timeout of 1. So we got 254 packets. We got 99 answers. I hear you got packet problems. I feel bad for your son. I got 99 packets, but a lot of syntax ain't one. You can see that we've got a bunch of just resets right here. That means that port is not open. So we got reset ACK, reset ACK, reset ACK, reset ACK, reset ACK. So now we can see the ones that actually had a response. We can do a sniff count. We can do a summary of the sniffing. So we're doing sniffing. We're getting 5 packets, and I want to see a summary of those packets as well. Now, if you want to look at what you can do, as I said, it's just a lot that you can do a Scapy or you can do a Scapy, like a ridiculous amount that you can do. You can do ls and then put in the parens here, and it's just going to show you all of the different protocols that Scapy can work with. If you do ls TCP, all of the TCP header fields you can modify, so you can train it. You can also run individual like cool networking services like traceroute. So I can do traceroute and then autocomplete. So you can do trace, hit tab, has autocomplete, and then I can put in Google, max TTL is 8, max timeout is 5, and it does a simple traceroute to Google. I can create a DNS query packet. DNS query equals, we're naming it DNS query. The IP header, we're going to modify the value of destination to be 8.8.8.8. We're going to stack that on top of a UDP header. We're going to modify it to be destination port 53. And then we're going to put in a DNS payload where we're going to put in a DNS query, and the query name is going to be example.com, and we're going to look for the A records. And then we can show that DNS query packet, and then we can send it. Going to send it. Send and receive 1 DNS query packet, timeout of 2, verbosity is 0, and then we get our responses back. All right. So this is really just barely scratching the surface of what you can do with Scapy. It just really, truly is. There's so much more that, I mean, it's literally a Python library. So anything that you can do as far as packet creation is there and ready to go. So what I'm going to do, speaking of there and ready to go, I'm going to very quickly load up the next lab and get it set up before GitHub goes down, because it's kind of been that kind of day. Here, it's a very blustery fall day. It's one of those days that you just want to snuggle up with a good cup of hot apple cider and just skip over labs because AWS is on fire. All right, so that is Scapy, right? That's just getting started with packet creation. Now, I already showed you a lot of what we could do with Shodan, and one of the things I didn't talk much about Shodan is you all should go out and get a Shodan license. I would watch out, though, for specifically the Black Friday sales, because Shodan, like if you look at the account, it's just a standard overall, account that I have on it that I can do a lot of cool stuff with. But the coolest thing about it is I think I got a lifetime of access to Shodan for I think $25 or was it $5? So I believe I have the freelancer plan, right? So I can do 1 million results per month, and I can monitor 5,000 IP addresses, most of the filters, right? But if you wait for their Black Friday sales, you can get it all for like $5 for life, which honestly, to be completely blunt, is brilliant marketing because I use it so much. We're now incorporating it into, we're basically going to be incorporating this into our SOC, and also into the new version of AC Hunter, which you're going to get introduced to AC Hunter a little bit later. But it's going to be a thing that we are going to be doing where we're going to integrate this, and that's going to be a lot more expensive. So by giving it away to me for free, they're going to get me into like $1,000 a month plan for the company here shortly. So you should absolutely be looking at Shodan and playing around with it. Now, Shodan, their top ports that they're collecting information on are standard web ports, 80, 80, 80, 443, 8443, as well as FTP, SSH, Telnet, SNMP, or Simple Network Management Protocol, IMAP for mail, SMTP for mail, SIP for voice over IP, and RSTP for voice over IP and streaming. So these are the main ones. And actually, they pull a lot more than just this because I showed you Mongo. That's something that's not on this list. There's a ton of different services that Shodan is grabbing the banners for. So this is also like really, really cool because I can do things like, let's go to Shodan. Let's go to Scan Me. Let's do something here. Let's have some fun. Oh, look at my Scan Me is done. That's cool. That up there, pull this up. So whenever I scanned this particular system with Nmap, it first comes back and it says, well, here's the ports that are open. We have 22. We have open SSH. Here's the key fingerprints associated with it. Then we have the title, go ahead and scan me, the Nmap project. We have the nping, TCP wrapped. What do we got here? The operating system is Linux. Awesome. We got the Linux kernel. Here's the trace route information. And then the operating system identification is a Linux system. So let's say I want to play around with Shodan on this system and see what Shodan sees on this computer. So I can go back to Shodan, put in that IP address. And Shodan says that these are the ports it has. We have 22. We have 80, 123, 9929, and then elite are the ports. So that's kind of neat, right? And then it says, well, we've got some vulnerabilities here, mod SSL configuration vulnerabilities. We have a handful of vulnerabilities on it, which is cool. So it almost does some vulnerability scanning as well. Okay. But I can do some additional cool things, right? I can put in that IP address. I can do 0/24. So this is classless interdomain routing or CIDR notation. So what did I just put in? So if we're looking at this, we have these each represent an octet. Okay. So there's there's 8 bits there, 8 bits there, 8 bits there, 8 bits there. So the first octet has 8 bits, second octet has 8 bits, the third octet has 8 bits, and the fourth octet has 8 bits. So whenever I do this, I'm saying I want the first 24 bits to match. So it's going to look for anything that begins with an IP address of 45.33.32. And then it's going to pull back everything that has anything from 1 to 255 on the last octet. So let's do a search and let's take a look at the neighborhood, right? So these are the systems around the Nmap ScanMe system, right? And we can see that it's in Linode, which is a cloud hosting provider that's out there, right? So, and by the way, that 24 is 8 plus 8 plus 8. 8 plus 8 is 16, plus 8 is 24. So it's going to match the first 24. If we matched it all the way, it'd be 32. If we just match the first 2 octets, it would be a /16. So here we've got a cloud web server. This one's running in Nginx. Just have a number of different servers running here that are in this neighborhood. So, oh wow, look at that one. That one's interesting. This one's actually a default web page. There you go. some default content on the internet, right? So we have those banners. So once again, Shodan gives us that banner information, allows us to query that banner information, and then we can find out more about the systems. So once again, the reason why this is so powerful for you as you're getting started is when you're just kind of learning, like what are the different services that are around your network at home. So let's go ahead. There's a bunch of websites. I'm not going to give it mine because I had students DDoS me once, which was cute. But you can go to what's my IP address. So if you ever want to know what your IP address is, just do a Google search for what's my IP, and there'll be a number of websites that'll give you your IP address. And then you can see what does Shodan see on that. Another question is, can't we manipulate banners to mess up Shodan? You absolutely can. And what class do we talk about that, Brian? Brian's helping out. Oh, I don't consider it a bad thing. I mean, kids being kids, right? Yeah, the active defense harbinger distribution or the active defense and cyber deception class is where we talk about how you can manipulate the banner information to become a little bit harder of a target as well. All right, so now we're going to talk a little bit about TCP dump. If you saw over here, I was running TCP dump earlier. So I do this. This is just local loopback. And TCP dump gives me an incredible amount of power for me to see what is actually going on my computer system. And I'm just going to kind of demonstrate some things with TCP dump. We had these netcat listeners, which we're going to play with here in just a little bit. I'm going to add in a flag, don't resolve. Here we go. So now it's just going to give me the straight ports and what we get with TCP dump, and we make connections with it and send data back and forth. We can now see the ports that are going back and forth. So here's me talking to myself, which should be no surprise to anybody whatsoever, right? So with TCP dump, the first thing I did is I ran my interfaces because I forgot what Mac did with the interfaces, because I tried LO because that's the standard loopback interface. And this is a standard Mac, and this is just terrifying. I mean, look at all of these different interfaces that are running. Now, a lot of that's because I'm running VPNs and I'm running OpenVPN, and I've got other VPNs for CloudFront and things like that. But my local loopback adapter is this one right here. So whenever I'm doing demonstrations, I'm showing you me communicating with myself, from myself to myself on my local loopback. And instead of it being LO, it's on Mac, it's LO0, as though somehow you're going to have multiple local loopback adapters, but I guess it's possible. So it's differentiating that as the primary local loopback adapter. And I can see all of those interfaces by looking at the interfaces with the -D to see which interfaces are running. Now, I can change this up a little bit, and I can start looking at the hexadecimal and the ASCII of what's being sent. So let me go ahead and do that. Go ahead and do that. Oh, that wasn't what I wanted. Let's do X and A. There we go. And now I'm going to send a whole bunch of A's through. From myself to myself, we're going to send hit enter. It's going to show up here on the other side. And if I look, you can see that I sent that packet right here. So this is the hex 45. That's the IP header. So this is all the header information. And then right here, you can see the payload that was sent was right? And I can respond back with, do that, hit enter. And then I can go back to TCP dump, and I can see a whole bunch of B's coming through. So I can see the hex, which is 42424242. And then I can see the corresponding ASCII, which is a whole bunch of A's or B's. Now, let's talk about that hex and that ASCII for just a couple of seconds, right? Because you see the ASCII is B, 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 capital B, capital B, capital B. And then the corresponding hex is 424242. So if you want to know what those are, you can do man ASCII and it's going to give you the man pages that's going to give you what the octal and hexadecimal values for different characters are. So if we look here, you can see a capital A is 41, a capital B is 42, capital C is 43, and so on. Now, what movie was playing around with hex? That actually was a central theme of hex. There's only so much data that can be sent. Somehow we can send videos. It's kind of cool. My kids got all excited about it when they saw it. The hug of death. The Martian. That's right. The Martian. He's using hex to send messages back and forth to mission control because of very, very, very limited amounts of bandwidth going back and forth from where he was at. There we go. All right. So I can also do specific filters. And here, got to turn on my heat in my garage. It got warm. Or it got cold, rather. I would like it to get warmer. There we go. All right. So if you noticed, I kind of ran into a situation where I'm getting more than what I'm bargained for, right? So let me quit out of this and let's rerun this. And it's not just the stuff that's going to and from port 2222. There's a lot of weird things happening on my computer system that is kind of poisoning the data. Like there, I didn't do anything. I don't want that. Like what is this crap? It's listening on port 54313 and it's coming from 6789. Like I don't even know what is this garbage? All right. So if I don't want that, I can use a port filter where I can put in the port of interest. So I can do port 2222, right? Now I'm just grabbing packets that are going back and forth on port 2222, either the source or the destination. So now whenever I hit this, it's just showing me the data from our connection. So we can go back, we can kill this connection, kill this session, go like that, rerun it, and I can rerun my Netcat listener and connect to it. And now I can see that perfect TCP IP three-way handshake, right? So now I can see where, there we go. And then this system and it acknowledges that sequence number by incrementing it by 1. See that? And now we establish connection. So now if I start doing the A's, B's, C's, and D's all over again, we go ahead, hit enter. Now it's just filtering out the data that is of interest to me. Okay. It's not showing me all of those other weird things that are out there as well. Are we seeing some Zoom lag, everybody? Is Zoom getting weirded out? That's not good. So here we go. We're going to keep going. Is it just lagged or are we dropping? All right. My connection seems good here. It's my video. So what I'm going to try to do is I am going to try to kill my video. If that's okay with everybody. Let's start using less information on Zoom or less data. There we go. And now just the BHIS, like kind of quasi skull and crossbones. All right. So the reason why this is so incredibly powerful is when you're reading in packet captures, right? Like a tremendous amount of what you'll do as a SOC analyst is you're going to read in a packet capture and you're going to analyze that packet capture in an attempt to try to identify what actually is going on in that packet capture. And usually you're going to start with a host of interest, right? You're going to start with one particular host, like someone says, my computer has Cookie Monster and he's going all over my screen and he's eating my screen. So let's see if I can find a Cookie Monster virus. If I do a Cookie Monster virus, if we go to a video, I don't know about you guys, but the internet just seems fine on Google. So let's say you're getting this.
The virus in the database.
What's happening?
It's replicating, eating up memory. What do I do?
Like cookie, you idiot.
There you go. That's how you solve that. I don't know. Could you guys hear that okay? Maybe I should just share the link.
Virus in the database.
What's happening?
It's replicating, eating up memory. What do I do?
Like cookie, you idiot.
Is that Penn Jillette from Penn and Teller? I think that's Penn. That is totally Penn. I didn't know that. Yeah. All right. So it's Cookie Monster virus. All right. So if you're fighting the Cookie Monster virus, he's going through and he's saying, I want a cookie. Give me a cookie now. And he's eating up all of the memory on your computer system. Odds are you're going to start with the IP address of that system to start researching what's going on. So we would go through and we would read in a packet capture, and then we would put in the host of the IP address that has the Cookie Monster virus, right? To try to see if there's different types of things that are out there that we could try to find out if any other systems are compromised with the Cookie Monster virus. So when you're working in a SOC or just straight information security, we work in packet captures like all of the time. Like I think it was probably within my first week as an Infosec like analyst for Anderson Consulting that I was reading packet captures. I mean, it was just something we were doing constantly. And for attacks and doing analysis, it was just kind of our life and what we did. So really, you gotta get familiar with the idea that you're going to be dealing with packet captures and slinging them around and all those things all over the place. All right. So we can also write out to a file. This is kind of the inverse of that, right? So you have a system that is getting weird Cookie Monster vibes, i.e. this, and then you want to do a packet capture on a firewall or some type of device, maybe even the system that you think is compromised, you're going to be wanting to capture the traffic. So you would do W to write it out to a file to be able to write that data out as well. All right. So at this point, what we would do is we do a lab with TCP dump. So what I'm going to do is I'm just going to kind of explain that lab, and I got it loaded here so you can see it, right? So what you're going to do on Thursday now for the labs and what we're going to do is you're going to play around with TCP dump, right? Just going to have a good time, like just how we start looking at packets. Now, one of the problems that you run into or people run into in this class is why do we use TCP dump? Especially whenever we get to Wireshark in the next lab. Because whenever we get to Wireshark in the next lab, you have people that are like, why would you ever touch TCP dump? Like Wireshark seems so much better than whatever this is, right? Like this is just a lot of like, what the hell? Like who hurt you to think that this is something that's fun for people to play with for capturing packets? Like, why don't you just use Wireshark? Well, look, TCP dump is an incredibly powerful packet sniffer, and the use case is completely different than something like Wireshark or Network Miner. The use case for TCP dump is such that number one is it's way faster than Wireshark. So if you have to do very high bandwidth packet captures on a network, you're not going to use Wireshark. Okay. If you have a huge packet capture, there's a very strong possibility that Wireshark will absolutely give up the ghost and trying to process that packet capture. So we use TCP dump all the time in a way for, number one, capturing packets to do analysis on. Number two, it also gives us the capability with very large data sets to go and use those filters to be able to do analysis on the packet capture. And then, believe it or not, we can carve it down and then open it much easier in Wireshark. So let's say, once again, you have the Cookie Monster virus, right? You want to capture all of the traffic for just that one IP address. You can filter it out with TCP dump relatively easily. So you're going to open your Kali terminal, you're going to become root, you're going to CD into the op TCP dump directory, and then you're going to read in a packet capture of some malicious traffic. This is a backdoor called Magnitude. I'm going to share with you here in a little bit. We have a wonderful website called Malware of the Day at Active Countermeasures, where you can experience and play with a wide variety of different packet captures of different malicious and quasi-malicious packet examples. You can play with those as well. So this is one of those. And once again, we would usually start by doing analysis on a host or a subnet, right? So if I'm interested, I'm going to be interested in host 192.168.99.52. That would be my Cookie Monster virus infected computer system. So I want to look into that computer system and do additional analysis. Now, usually when you start using TCP dump, you're usually just starting to make sure that the packets you're looking for are present and accounted for. And here we do have packets between that system. And we're going through and we're explaining what the timestamp is, what the protocol is, what the source IP address is, and destination fields and things like that. Then we focus on port 80. Much like I did in the terminal here just a few minutes ago, right here, where I created the filter where we were focused on port 2222. We can do that filter within TCP dump on a live packet capture, but we can also do that same type of filtering on a read or a packet capture that we're reading in. So N means don't resolve any names. I don't want you to try to tell me and get cute on what port you think it is TCP dump. I just want you to tell me exactly what the number is. We're reading in the magnitude 1 hour PCAP. We're filtering by host, the IP address, and just port 80. So now if we look in a little bit deeper, we can do A because we want to see that ASCII. So whenever I did TCP dump over here, I did X and A, and the hex many times just kind of gets in the way because let's be honest, there's not a lot of people that can read straight raw hexadecimal. So you can also configure TCP dump so it just gives you the ASCII without the corresponding hexadecimal. I still do because I'm old and hex intrigues me. I feel like I'm really hacking when I'm looking at raw hexadecimal. And if you scroll down, you can see that we have some GET requests that have some weird gibberish associated with them as well. So we can see the different responses. And if we dig in deeper, you can see that we have this string that says new object IO memory stream. Now I can look at that and I can be like, yep, that's totally a PowerShell. Now, let's say you didn't know what that was. What could we do? I'm going to try something real quick. Right? Oh, cool. It's going to work. I could take that and just dump it into ChatGPT. Right? You could also just do a straight copy and paste of the PowerShell, and you could just dump it into Google, and Google would come back and it'll tell you it is PowerShell. But look at what ChatGPT does, right? ChatGPT breaks it down. This is PowerShell code. Let's break it down. We have new object IO memory stream for base 64 decoded string. It's going to start with the blob and it's going to convert it into gzip compressed data. And then it decompresses that data. Now, this is kind of weird. Oh, it does right here. So this is definitely malicious. It is definitely an attack because that's our malware on that as well. And then it gives you additional next steps on what you can do to unzip the payload and inspect that payload. That's pretty cool, right? So my point in all of this is we can use TCP dump to get to the point where we have something of interest, and then we can delve into it using ChatGPT to try to get a better understanding of what that packet capture actually is. Now, we're still at the point where we have to kind of be on our own devices. to be able to identify and whether, the concern is and how we're going to react and contain that breach. But it's really helpful for us to actually do that. Once again, though, like seriously, if you just give this whole packet capture to Chat GPT, I'm pretty sure it tells you to F off. It doesn't like that. But if we can just drill in on that one thing that is of interest, it gives us tremendous power, right? So we can look at the hex and the ASCII if we give it the switches A and X as well. Then also we can read in a packet capture and look for different protocols like IPv6. You can put in LLMNR, link local multicast name resolution, and a number of other protocols to be able to identify what actually additional weird things are in this packet capture. So overall, pretty cool stuff. Alrighty. So now what we're going to do is we're going to move on. We're going to talk about Wireshark. Now, as I said, a lot of people, whenever they first get started, they get really, really uncomfortable because they are always looking for what is the best tool. What is the best port scanner? What is the best vulnerability scanner? What is the best packet analysis tool? And I believe that that's very much a mistake on a number of people. Like, we shouldn't be just focusing on what is the best, because to be honest with you, a lot of tools have pros and cons, and a number of tools have additional features that make them incredibly powerful in ways that normally you might have to use multiple tools to get to the answer that you're actually looking for. So as I mentioned, TCP dump is really great because it is fast. It is wicked, wicked fast, very powerful for doing packet captures and doing large scale packet filtering on the traffic that's coming and going across your environment. However, once you get that packet capture kind of carved down, you're probably going to use Wireshark. And Wireshark is going to be the tool that's going to be that graphic representation and show you and break down and kind of do a little bit of Scapy type stuff, where it's going to start explaining that packet in a way that's going to make sense to you as well. Now, very similar to TCP dump, where we use -D, Wireshark, when it starts, it's going to show you all of your interfaces, right? It's going to show you all the interfaces that you have to choose from, and then you can double click on them. Now, one of the cool things about the interfaces is it's going to show you which of those interfaces is sending and receiving traffic. You're going to see this through a little graph over time. You're going to see little spikes and valleys. So you won't waste a lot of time capturing packets on something that's not actually sending packets, because that would be really, really, really weird on that as well. So you can see it, then you can drill in, double click, and then it's going to start showing you the packets. Now, when it shows you the packets, it shows them very similar to TCP dump. It's going to be in a list format, right? So if I go back to TCP dump here, let me kill this really quick, and I'm going to get rid of the ASCII decode. I'm just going to show the individual packets that are being sent. You can see that each packet is kind of its own line. It starts with the date timestamp, gives you the protocol, the source destination, but you see that date timestamp is the beginning of each packet. Wireshark does that same type of thing. It gives you kind of the offset of time when the initial packet capture was created, the source, destination, the protocol, the length, and then additional information about that specific packet. So if you were to ping back and forth, you would be able to see each request and the response coming back and forth as discrete packets independent of each other. So very, very cool. Once again, seeing that graphic kind of visual representation of the traffic is very, very powerful. Now, at the bottom, you can see that we have these like areas. We have the hex down below, and then we have this middle area. The middle area is an area where Wireshark is going to describe the actual packet itself. So you can take that packet up above, but then it's going to describe it bit by bit by bit what that packet does and that breakdown. So I can see that this is an Ethernet frame. Destination is a VMware OE, or organizationally unique identifier. We can see it's coming from a source IP address of, or MAC address of 000C, what is it? 2946620B, right? We can see the source and destination, and you can expand and collapse each of these and get additional information about what that means. Now, one of the other really, really super cool things about this is as you're selecting in that middle area, it is also highlighting the corresponding hex. And this goes both ways. You can select that area in the middle, and it'll highlight the hex, or you can click on the individual hex values and it'll highlight the area up above as well. If you have a TCP IP stream, remember we were talking about SYNs and SYNACs and the traffic going back and forth, and we did that whole Mars attacks pedagogical technique, SYN, SYNAC, ACK. That series of ACKs, right? And we got ACK, that's part of a TCP stream. So within Wireshark, you have the ability to follow that TCP stream and it'll reconnect it and it'll pull out just the application data that it can see if it's not encrypted. So if we right click on HTTP traffic and we follow the TCP stream, you can see the red is the requests and the blue is the packet content response. So we don't have to worry about the header information for the IP and TCP header. We don't have to worry about looking at the hex. We don't even have to worry about going each packet. It's literally going to reassemble the whole thing. And we can see the entire conversation between these two computer systems very, very, very easily. So if you want to do quick analysis, TCP streams are the bomb. Now, the real power for me, and in addition to looking and decoding the packet payload details to identify what is inside those packet payloads, statistics. Now, I know, I'm sure some of you at some point saw when you were thinking about taking this class, you're like, is there going to be math? And you looked at me and you thought about it, you saw the picture of me and you're like, that guy looks like he doesn't math very much. And you'd be right. My lovely wife is an engineer and she's the mathy one in the family. I learned just enough math to get something into a program like Python and then let it do it for me. I remember I was helping my son. He was learning algebra and we literally just sat down and we learned algebra by writing Python programs to solve algebra problems for him, which is kind of funny. They allowed him to use like TI 85 and 86 calculators in his class. And, it's one of those things where, we're using calculators. And I remember the teacher was like, well, if he wrote a Python program that he can put into his calculator, that means that he's not truly understanding how it works. And I'm like, kind of halfway don't think you understand how math and coding works, right? So it was just a different way of dealing with it. But it turns out the statistics that we're doing, pretty lightweight. We're not doing anything super duper heavy, and we're not going to be doing eigenvector values or anything for like aircraft reentry or rockets. It's not rocket science. We're just going to be seeing like, what's the most top talkers? What's the least top talkers, right? We're just going to be doing some really, really basic stuff. So what you can do is you can look at statistics and then you can drill in and you can see who's talking to whom. And notice all of these, we have packets and bytes. You can sort any of those so you can see who are the top talkers sending traffic, who's the top talkers receiving traffic. So let me give you an example. Almost any system in your environment is going to be receiving a lot of traffic from the internet. You're going to see a lot of little tiny GET requests going out to the internet and very big responses coming back. There's not going to be a lot of parity. It's going to be a lot of very small requests and a lot of data coming back. If you have a system that's sending a tremendous amount of data out to the internet, that possibly, I'm just throwing this out there, that could be bad. It could be bad. You might want to investigate that. But how would you be able to first identify it as a problem? Turns out you would start with Wireshark, right? You would do that, who's sending the most data, and then start investigating where that data is actually going. So we can look at that through conversations in Ethernet, IPv4, IPv6, or TCP. And in this situation, we have 122 TCP conversations, and we can sort any of those conversations to do additional analysis on those conversations as they go out. We can also look at the protocol hierarchy. This is one of the things that I love. And it is, I understand, kind of a bit geeky, but I like to see what are the protocols that exist on a system, right? Whenever it's communicating or on a network. Now, why? Well, one of the reasons why this is really important to me is because when I'm doing pen tests, which I haven't done in years really, but when the people that work for me are doing pen tests, I sometimes tell them you just got to sit back and just sniff, what is it? Stop and smell the roses. Sometimes you just got to stop and sniff the packets, right? So you're going to sniff the packets and get an idea of what the protocols are that are on the network. Now, we're specifically looking for protocols in that scenario that are known to be bad packets. Like we just do not want to ever see that if we're doing cybersecurity. There'd be protocols like if we see STP, like spanning tree protocol. If we see OSPF, open shortest path for or RIP that's being broadcast, or if we're seeing LLMNR, link local multicast name resolution, or NetBIOS name service on the network, or WPAT. These would be protocols that you would never want to see. And you can find those protocols utilizing Wireshark and then doing analysis on them as well. We can also look at the HTTP requests. Now, I had mentioned earlier that you're going to see lots of small requests that come back with very big responses. So if I were to go to some website like yahoo.com, like just say, it's funny, I go to yahoo.com because it's like no one gets offended by Yahoo. Oh no. Is Yahoo down? No, it's just slow. All right, so much for not being offensive, right? But if you look at Yahoo, you can see that you got your morning brief, you got politics, you've got shopping and lifestyle, you've got your Jiffy corn casserole in the kitchen, right? So that simple request for yahoo.com, Yahoo still exists, just generated a tremendous amount of garbage coming back to my system. So you have a very, very simple request that leads to a much, much, much larger response. So we can focus by looking at those HTTP requests. And here you can see that we have tile service weather.microsoft.com. We have windowsupdate.com. And then we have this weird one. It's not resolved. It's just the IP address. We have 104.248.234.283. All right. So all of that together is like, what are we going to focus on? Are we going to focus on the weather? Are we going to check and see if we have malicious Windows updates? If you're doing that, you're wasting your time. But if you're going to focus, I'd recommend focusing on this one IP address that is not even resolved, right? All right, so what we're going to do now is we're going to take a quick 10-minute break. Then I'm going to come back and I'm going to talk about Wireshark. And then I'm going to walk you through the Wireshark lab. And then I'm going to kind of get us ahead on tomorrow. I'm going to talk about the Linux section of this class. And when we land tomorrow, hopefully our Amazon woes will be somewhat rectified and fingers crossed, right? And we're going to do the lab walkthrough for Linux tomorrow. All right. So we now have 3 labs: Wireshark, TCP dump, and the Scapy lab that you guys will be doing on Thursday in the open lab section for this class. And all of this is recorded. It's going to be saved. It's all going to show up in resources. All right, so let's hit that timer. Let's do it for 10 minutes. All right.
Oh, there you are.
Yeah, no, I just had to go back and get a beverage. So everything still looks like it's on fire?
Yeah, appears that way. Isn't that so much fun when this happens?
Just gotta roll.
This is a rarity though. Like the time frame for this.
It's kind of funny. We talk about it a lot at BHIS, like whenever we moved into the cloud. Like I remember years ago, whenever we moved from standalone email servers to Google Mail. And, you had all these people like, oh, the cloud is just someone else's computer and you don't have control. And one of the things I always talk about in my classes is if let's say that we ran our entire lab infrastructure, Zach, like the whole thing, and it was at BHIS, it was in the Sturgis office, it was upstairs, and we were in complete control over it, right? If we did that and we had an outage like this, 100% on us, right? We would have to own this 100%. But whenever it happens, and I was going through all the websites that were down, all of the services that were still not coming up, it's not something that's blamed on BHIS or anti-siphon directly. It's almost like an act of God, right? So what is the news story? Is the news story that we're down, or is the news story that Amazon went down and we're just one of the victims? And that second kind of way of looking at it is really powerful, right? From kind of moving that risk on to Amazon in this situation. Now, I do think Duolingo is still down, huh? Okay. There's all kinds of websites that are still down. So I don't know. I think it's going to make Thursday a little bit interesting, just kind of open lab time for people. But once again, the big thing that we try to drive is once it gets back up, it's up. And I do know that I'm going to have instructors, by the way. They're going to be like, oh, I don't know if I ever want to do that because Amazon went down. How many days of training have we had that have been pretty much flawless with Amazon? I mean, we moved over here, what, a year ago, 2 years ago? When did we move away from Cloud Labs to this one?
With Roman, it's been about a year now.
Yeah.
With you for sure, yeah, and
So,
at least a year.
yeah.
But yeah, have not had this issue at all.
Yeah.
And again, like this is the longest I think I've seen this happen in a long time. I can't remember the last time we've had it where it's been just ongoing this many hours. And it's only been like what, six? I'm not going to do it. Maybe like 8 hours. I was going
Yeah.
to do the bit.
Yeah.
But that's the 8 hours. That's a long time for these like websites and stuff to be down, these different services to be down. It's crazy.
I think it's going to be weird because I think that there's a lot of people that are going outside and touching grass and maybe they'll like it. And like going through the sites that are down, like I think Tinder's down. What's the other one? Grinder's down.
Oh no.
Can't you got to get that going. It's weird. I saw that Discord was on that list. That Discord was having issues. I haven't. Discord's been pretty solid today, right?
Yeah, I haven't seen any issues at all with Discord at all.
Yeah, it's probably all the Minecraft. Like they put all their Discord servers that mean something to them. Like we're probably EC West or something. Like yeah, put them in Sacramento for this stuff. So all right, let's keep going, and I want to get the stuff set up for Linux. So we're a little bit ahead. So we aren't eating too much time at the end. But no, we got Canva. That's the one that my daughter was blaming me for. I don't know if you saw that, Zach.
Yeah, oh yeah, I saw that.
Daughter's
She
like,
texted me.
Canva's down. Are you pen testing Canva right
Yeah,
now, Dad? It's
that's
like,
hilarious. I
well,
love that. Yes, we pen test all of the things. Every
yeah,
time something's down, it's
it
BHIS. We're
does.
giving
Yeah,
them some kind of hug of death, one way or another.
one way or the other. I'm hoping like when we get to I'm really excited about that new email lab. We did that mini CTF. That's now part of this class. So what was that 2 weeks ago? We did the email analysis, CTF, mini CTF. So,
Yeah.
but that's now part of this class. So I'm excited about that lab this week. So that'll be fun.
Are you going to do the walkthrough today on the news?
I don't think that we had one last week. Did we do one?
Well, I was out all week, so
I,
I don't think
so
we did
what
one.
what Jason did the last one is he just posted the write up.
Okay.
And that was kind of it.
All right.
Oh, actually, we know we have the Alyssa and Caitlin. Were they the ones that did that one? I don't know if we have any of them
Yeah.
sitting out there, dude. If we do, we've got to share the solution. So I'll probably share out the solution for it. But yeah, let me
Yeah, I'll
know.
look for
Like,
it. I'll
yeah,
look.
let
I'll
me
double
know and
check
then
for sure.
text
All
me
right. I
because we
got
might be
you.
doing that in the news today.
All
So
right, I got you.
yeah, Alyssa did one. Okay, so we do have one out there that we will hit at the end of the news. So I got to get that solution. Did Alyssa send that to you too, or is it just to me?
I was just searching right now.
Dude, if you want to get that and get it up and we can share it in the Discord server with her solution, we'll just do that. Sound good?
Yep, got it.
And then if you want to pick a couple of winners, that would be
Yeah.
good. By the way, what Zach and I are talking about is something new that we're doing at Black Hills Information Security's Tribe of Businesses webcast. So there's a lot of companies that now have webcasts, and it's kind of cool, Zach, actually. I'm looking at some other organizations, and they're kind of following our lead. They're doing a lot of really cool like webcasts on a number of different timely topics. But we're looking at it and we're like, that's neat. So everybody needs to up their game. So what we're doing now is for our webcasts, we are kicking out little cyber challenges around the webcast. So it isn't just this passive thing. If you want to, you can actually interact with the webcast. So at the end of the webcast, we release a little tiny CTF challenge that is created either by us or by the presenter or a conjunction so that people can actually experience and kind of get their hands dirty with what we discussed, because we're just trying to level this stuff up as much as we can, like tons of hands-on.
Yeah.
So
Yeah, it's super exciting just because it creates like a whole new like level of like engagement. And we just want to encourage students, as much as possible to get their hands on the keyboard. And I think that's what's really the most exciting part of this is just like, okay, well, yeah, you guys stick around for the webcast, you watch what's going on, which is great. We love that. But now you can like actually get your hands on the keyboard and do something, and that just speaks just volumes for
we need to create
everything you can do.
we need to create either a t-shirt or a keyboard that literally we can call it the jealous keyboard. That's like, don't touch grass, touch me instead. Um,
Oh, wow.
I don't know what you can do with that theme, Zach, but
Yeah.
I think it would be, like I said, a jealous keyboard or something like that. And we could actually, I think, wonder if we can get custom keyboards that say that on the front. Don't touch grass, touch me instead. And let's see what we can come up with. But we got to go. I got to get to the
Yep.
lip
Sorry. I'll
where
get
you're
head
going to be
backstage.
teaching
I'm
a
gonna look
lot
at.
more than you want to teach on Thursday. So, all right, let's get
All right.
rolling. Thanks, dude.
Yep.
All right. So we had another lab that we are going to kind of not jump over right now, or we're going to jump over right now, is understanding ASNs. And I will, yeah, this one I want to do tomorrow because it's a relatively short lab. So if someone can just take note, we'll do that because I want to get into Linux. Right. So we're going to spend a few moments and we're going to talk about Linux as an operating system. This is usually where we would begin with day two. So we're getting a little bit ahead because we haven't done a lot of labs. We're putting those labs kind of on Thursday. So in this section, we're going to go through some of the core Linux commands that you would use to do analysis on a Linux computer system that you think is compromised. And this definitely can mean the difference between a quick incident and a very long and dreadfully painful one. And this, like, one of the questions I get all the time, and I should have Zach back on. I don't know if he took off, but oh my God. Somebody just posted something on Discord that said when your girlfriend was on AWS US East 1, and it's a screenshot from the latest Blade Runner movie. That cuts deep. But Zach,
What's
I
up?
get people all the time that are like, Linux is more secure than Windows, right? We hear that all the time, and it's not really all that true, honestly. Um, it- it-
All the time. I
yeah,
I mean, I remember just like forever being intimidated by Linux because everybody made it sound like you had to be some elite hacker just to touch it, right? Like honestly.
yeah,
And it was like 12, 13 years of my IT career before I ever touched a Linux box. And I was terrified, like absolutely terrified. And then the sysadmin I was with was like, dude, just come here and sit down and look. And he
yeah.
walked me through it. I was like, oh my, like,
What have,
you
what have
know,
yeah,
yeah, what have I been afraid of this whole time? Like, and then he's like, yeah, and it's not as secure as Windows. And then he kept, like, or, it's not that it's not secure. It's just, it has its flaws. There are things where there can be vulnerabilities, right?
And,
But
and I think that a lot of people, like, they don't know anything and they're like, we're going to run Linux because it's more secure, and they don't update, they don't patch, they don't maintain their system. And I think you would agree, you're only as secure as the sysadmin or the security people that are protecting it. Like, Windows absolutely can be more secure than Linux, and Linux can be more secure than Windows. It's really dependent on the team.
or dare I say the user, right? I
Oh,
mean,
yeah, that's true. True. Even
that's
though
that's the most difficult part, How do we fix that?
So one of the questions we just got is, do we actually use AV for Linux? I hate to say it, I don't on a lot of my Linux distributions that I stand up. Now, I'm not surfing the internet and general purpose computing. I use my Mac, which we do have Lima Charlie and other AV on. But nah, it's rare to see it. And I think honestly, a lot of the AV for Linux is kind of not good. I don't know your take, Zach.
How often would you say like you or and especially like our team as security professionals who are using Linux very often are really starting fresh very frequently, right? Like a lot of times there's they may have a dedicated kind of build, but I think often they're running from a VM or some type of like image or something, or reverting back. So I guess I'd be interested in like how they utilize Linux as a daily driver, you
Yeah.
know.
And I love Linux. I kind of start the session. Linux is my favorite operating system. It just is. I don't use it now. You see, I'm on a Mac, and part of the reason why I use a Mac is the camera is this is decent quality. Like, and also they do a bunch of cool lighting correction out of the box. And then the microphone, if you have auto like leveling setup, it's a good mic too. So for me traveling, you're probably going to see me over the next 3-4 days in 3-4 different locations. So with the amount of traveling that I do, it works great. All right. Well, thank you, dude. I'm going to
Yeah.
jump in and we're going to talk about some of the commands here. So the first
Fine.
thing that we're going to do is we're going to hit up like what are the directories that exist. If you look at a Linux system, you get the bin directories. That's where binaries exist. One of the great things about Linux, and I'm kind of really focusing in on kind of old school Debian style Linux at this point, is all of the directories and the way programs are set up, it's set up in a logical way. So your binaries are in the bin directory, right? Then you have boot, which is your boot loader files. So that's how your system starts. One of the cool things about Linux is when you upgrade your kernel, the old kernel stays. So if you do an upgrade and something blows up, like let's say hypothetically DNS something 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 DB goes down, bad things happen. And because someone did an update to Linux, you can just simply go to a previous version of your kernel and they will stay present there. Device files, every single device, your keyboard, your mouse, your monitor, everything is in the dev file. And that is incredibly important because everything in Linux and Unix is a file. Oh, that is really good. That did you just create that, or is that one? Did I come up with an idea that somebody already came up with, Roswell? Okay, awesome. I think we're getting really close to a shirt or a keyboard. Um, Zach, we've got to do this, man. We've got to do this. So it's coming. It's coming. The other thing that I love about Linux and Unix is the etc directory. So whenever you're working on where configurations can exist on a Windows computer system, configurations can exist in registry. They can exist in flat files. They can exist in alternate data streams. They can exist in a wide variety of different locations. If you're looking for the configuration of a web server on a Linux computer system, then you would specifically look in the etc directory because that's where the configurations of those different files exist. When a user logs in, they're going to have their home directory, and each individual user will have that. They will get their home documents, home downloads. It's very similar to the user directory on modern Windows computer systems as well. Then we get into lib. Just so you know, has nothing to do at all with politics, right? Like if you own the lib directory, it's not that you're owning the libs. Just being clear, we're not going to get into the politics of anything here. Desperately trying to stay away from politics. But the lib stands for libraries, all right? Which is equally avoided by all political parties. So keep that in mind, right? So libraries or lib, right? The library directory. Now, whenever you're thinking of a library, I want you to think of a literal freaking library, right? So if you think about a library, you would go into a library and you'd pull open the card catalog system. And when you pulled out the card catalog system, you would be looking for books on cats, right? Like cats, cats and hats, cats and dogs. And you would find a book of interest, like, cats in ancient Sumeria. And you would find that book and it would give you a number in the Dewey Decimal System, and it would tell you where exactly in the library that book would exist. You would go to a specific section, you would go to an offset, you would go to that part, you would find your book. Some Dewey Decimal Systems and card catalog systems were so good, they would tell you which page you would go to. I remember being a kid and getting really, really super excited about a monster card catalog in a library because you could get down to the page. That was one of the reasons why I loved going to the University of Wyoming. It's weird. That was a long time ago, you all. And that's exactly how your computer works, right? Like when your computer tries to load something, like you're trying to copy and paste, or you're trying to, move data from one part of memory to another part of memory, your computer system will use a variety of different functions from the dynamic linker to go through and try to find in the library where that functionality exists so it can update the operating system to have that capability. Right, so it can update it as well. So media is removable media. You plug in a USB stick, it'd be media USB. Mount, if you mount a file system. Now we're going to be doing this a lot starting tomorrow, hopefully. We're going to be dealing with mounting a remote file system. So your Linux system is going to mount the C drive of your Windows computer system, which is really super cool that you're going to be playing with as well. Opt. Now, opt is interesting because on Linux and Unix systems, opt is where programs that are completely self-contained tend to go. So if you look at opt, let's say you have something that where they want the binaries, the device file, the configuration files all to be together in one bundle, you can put that all in one bundle in the opt directory. SBIN are system binaries. Very much it's going to be binaries, but specifically for managing the system. Data for services that are running, like if you're running a server or a service on it, you would have data stored there. Temporary files, just that's what it does. User, that would be that further broken down to user bin, user SBIN, where user binaries and applications, and yes, even services can exist. Because a user, even though they're not root, can actually start a service on a Linux system, like a gaming server. Like you play Settlers of Catan, which you can totally install and run on your Linux computer system. You can run your own server and have your friends join, which is great. But sometimes I wonder, if you're running Settlers of Catan on Linux, do you actually have friends? Maybe? I don't know. It's kind of strange. By the way, I'm not shitting on you. Like if you're like, oh my God, John's making fun of you. No, I'm not. It's okay. I didn't date in high school either. It's perfectly fine. So we're in this together. All right. So let's move on. We've got variable files. That would be like log files. And then home directory for root, and then proc is a virtual file system. So I'll talk more about that a little bit later. So users and privilege. Anytime you're ever logged into a Linux system and you see a $sign, that means you're not root. Who are you? Not root. You could be John, you could be you could be someone else, but whatever it is, you're not root. At that particular point, you're not root. If you get a pound prompt, you are root. That means you're the all-powerful account on that system, right? So pretty cool. Directories. On Linux and Unix systems, I can list quote-unquote hidden files and directories, and that also works here as well. I think I need to close Yahoo. I said there'd be no politics, and I just open it up, and it's like, politics. There we go. It's not that I don't care. It's just not a conversation I want to have with people. Having conversations with people about politics is a lot like having conversations with people about what porn they're into. It's like, I'm not interested. I'm sure you're very interested, and that's great. That's fine. Not interested. All right. So let's exit out of this. Exit T. Let's do exit. There we go. If I do ls, these are all the files that exist in this particular section of my hard drive. If I do ls minus lrta, oh, I just lost it. Ls, let's just do minus a. You can see that I have these dot files. These files are hidden. It doesn't mean that they're maliciously hidden. They're just hidden. And they're usually configuration files for like Dropbox, for Python history, SSH, Z profile for Z shell. So these are files that I don't want to see all the time. I don't want to be working with these files and dealing with these files all the time, it just suppress them. So you can basically put a dot in front of that file or in front of that directory, and it's going to be quote unquote hidden. Now, as I said, many times it's used legitimately, but yes, attackers will absolutely hide files on systems as well. Making directory, easy. Very, very, very simple on a Linux computer system. Just make dir the name of the directory that you want to look at or want to create. There you go. That's it. Binding files. One of the cool things about Linux is it actually goes through and it indexes the entire hard drive. So all the files and all the directories across the entire system, it goes through and it creates an index of all of those. So if I touch a file, which means created, I'm not actually touching Sasquatch. I just realized after all the years of teaching this class, I don't think I've ever explained what the touch command does. So I think that all of my students think that I'm assaulting the Sasquatch, and that's not what's happening. Whenever you touch a file, you're creating a file of the name Sasquatch. Just letting you know, just not getting weird here on that. We're not going to have some island out in the middle of the Caribbean with Sasquatches running around. That's not what we're talking about. We're creating a file called Sasquatch. That's what we're doing. Now, my system doesn't know where that file is initially. So if I do update DB, it then indexes the entire system again, and then it learns where Sasquatch is. So then at that point, if I do locate Sasquatch, it'll tell me the Sasquatch file is in the home ADHD directory. Editing files with VI. One of the things I like to bring up is how many of you have never really used Linux before? Like you're all new, you're just kind of, you're a little nervous about this Linux thing. Just a little scooch, just a touch. Anyone? Anyone? We got a bunch of people that love Linux, and that's awesome. We got a number of people that have never used it. All right, that's cool. All right, so now I'm going to ask a question to the Linux aficionados in this class. What is your favorite Linux distribution? We got Debian just popped up. Ubuntu, ParrotSec. Come on, keep them going. Void Linux. Ubuntu again. Fedora. Debian. Ubuntu. CentOS, RIP. Rocky, Mint. All right, all right. Now, what is your favorite text editor? Everybody, what is your favorite text editor? Nano, 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 VI. We got Vim. Jesse's like, nope, nope, sorry, Nano. Notepad++. You know, you got some people that are hardcore. They're like Visual Studio. It's like, damn, drop the mic and walk away. All right. So for those of you that are new to Linux, that little conversation I had about distributions and editors, does any of that make you feel more comfortable about using Linux? Anybody look at that and they're like, yep, this seems great. This seems like a happy place for me. No, it does not. Nope, not even close. So I'm going to give you two things. The first thing is, don't worry about what distribution of Linux you're using. Learn Bash. So if you go and buy a book and you want to learn how to use Linux, don't buy a book on how to use Linux. Buy a book to learn how to use Bash. The Bash shell and all of the commands that we are using are for Bash, but they also work on all the Linux distributions. All right, so that's huge. Learn Bash. Number two, when you're learning editors, the two main editors you should learn are VI and Nano. Now, VI stands for Visual Editor. And once you're in VI, you can use A to start editing, hit escape to stop editing, and then you can press :WQ to write and quit. These commands, if you learn how to use just these in VI, you can actually spend a tremendous amount of time in your life working, getting very advanced with Linux and not learn anything more about VI. Now, if you want to kind of get started with something that's a little bit easier and user-friendly, Nano would be the one to do. With Nano, you can see at the bottom, it has usage information on how to use it. So you can see the little caret, that's a control. So control G means get help. Control O means to write out. Control R, read a file. Control W is search. And control X is exit. So it makes that usability a lot easier to actually have that kind of manual right at the bottom of it. So, which is really, really cool. So if you're getting started, Nano is a great editor. Just remember that the little caret is a control key. Now, if we want to see the processes on a Linux computer system, we can use the PS command. In this situation, we're running PS AUX, which means we want all processes sorted by user, including the ones associated with the sudo teletype terminal. The switches change the way the program presents the data to us as well. If you want to see something dynamic where it's updating constantly, you can run top. And this will show you which programs are running, the process ID on the left, the program name is on the far right, and it'll tell you how much CPU and memory that particular program is using at that specific time. If you want to get your IP address, you can use an IPA, and that'll show you your IP address. You can see I have my local loopback, my bond 0, my dummy 0, ETH 0. ETH 0 is usually the interface that you'll be using as well. However, I'm old and I use ifconfig. And Brian's going to be like, you're not old. You're not old. And I'm like, we can be varying levels of ancient, Brian. It's perfectly fine. You can be old. I can be old. I can be slightly less old than you. Maybe a little bit more than slightly less, but less old than you, Brian. So you can run ifconfig, right? Mature John. We're moving to you're the ancient one. Okay, I get it. I see how this goes. All right. I'll be old, you be ancient, and we're all in agreement. That sounds awesome. But ifconfig is another way of showing IP address. One of the things you'll learn on Linux and Unix systems is there is often more than one way to do the exact same thing, and that's okay. They have pros and they have cons. ifconfig is the one that I've been using since I was a wee lad at my dad's computer systems at Triad Control Data Systems. We would sit and run, various old computer systems, but ifconfig would give us the network interface information on those computer systems. Ping is just seeing if a remote computer system is responsive. You've already seen me run this command a number of times, but if I get a response, it means that system is alive and well. Nmap is another tool that I used earlier today where I can run a port scanner to identify which ports are open on a computer. All right. Ping, port, parse. If you ever have a problem trying to figure out what's going on, there's 3 simple steps. If you're just getting started in IT and IT security, this is going to take you very far in your career. Ping, is the system on remotely? Can I talk to it? Port, is the port I'm trying to communicate open? Parse any messages that I get back from that system to see if there's any errors. If you know how to ping, port, and parse and read error messages, you're going to do fine in your IT career. If I want to look at the network connections, I can run netstat. You're going to see this again for Windows. This is one of the rare commands on a Linux computer system that actually works better on on Windows than it does on Linux, which is really weird. But on Windows, we'll be using Linux, we'll be running netstat to identify the network connections there as well. My personal favorite command on Linux and Unix is LSOF. That stands for list open files. As I mentioned earlier, everything on Linux and Unix is a file. So if we've got a tool that allows us to list the open files on a computer system, that is really powerful. Don't get too excited about Linux being on, netstat being on Linux, because LSOF is the one you gotta know. Because if everything is an open file, I can run LSOF and I can see all those open files. I can restrict that to just the open files associated with an open internet connection with the I. P means don't try to resolve the port number, just give me the straight number. I don't want you to try to explain to me what that number may or may not be as well. All right, proc and processes. I love the proc file system. By the way, I'm going through this relatively quickly because we'll be doing this in a lab tomorrow. Right? We'll be doing this in a lab tomorrow. So proc is a file system that's weird because it doesn't actually exist on your hard drive. That's weird. Why? What does that mean? Proc exists as the system is running. So if you look in the proc file system, you see these numbers. You have like 160, 209, 286, 287. Those numbers correlate back to the process IDs that are running on the computer. So that means within Linux and Unix, we can actually jump into those process IDs and we can see what that process ID is doing. So if I jumped into 360, right? I can see information like what are the attributes, what is the executable, what is the current working directory, anything associated with net, what is it considered to be the root file system. And in particular, I can re-extract data out of the executable from memory to do forensics analysis on that executable as well. So if I were to run strings on an executable, which allows me to print the ASCII printable human strings, it could maybe give me usage information about what that executable does. Now, once again, I'm going through this fast because tomorrow we are totally going to be doing this together, slower with me walking it through with everybody. Bash history. If I want to see all the commands that a user ran, I can do history. Weird little quinky dink. If you put a space before a command on Linux and Unix, it will not, well, I shouldn't be very, on some distributions, it will not write that command to history. That's not a hacker thing, even though hackers totally use it. It is a thing that is intentionally put onto Linux systems because sometimes programs run with API keys and you don't want that API key written to your history. So you do space, run the program with your API key, and it won't be written to your history as well. All right, so that's it. We're kind of at the point where we're kind of at a shutdown because I don't want to go into Windows at all. But when we get back tomorrow, the first thing that we're going to do is we are going to be doing a Linux lab. At this particular point, we're not going to be doing an Ask Me Anything today. I've got to get some stuff in order and just need some help. And we'll hit the AMA tomorrow. The last half an hour will be a full Ask Me Anything. So with that, Zach, we ready to kind of wrap it up?
For sure. Yeah, I'm ready to go, man. Thank you
Yep.
so much for sharing all your knowledge today. Appreciate
Thank
it.
you very much for hanging out. All right.
Sure.
Let's
Thank
bail,
you, everybody.
everybody. See ya.
Have a good night.